Assalamualaikum Ibu Diah ya, Mbak Diah.
Iya, waalaikumsalam warahmatullahi wabarakatuh.
Alhamdulillah nih ada apa anggota dewan ada yang hadir ya dari Komisi 7.
Iya, insya Allah.
Terima kasih Mbak Diah.
Iya, sama-sama Pak Agung.
Pak If, ini kita kedatangan tamu dari Komisi 7 anggota DPR. Pak If lagi.
Thank you to our honor sponsor INDO EBTKE CONEX 2021, main sponsor by Mentari UK, Indonesia Low Carbon Energy Partnership, platinum sponsor by ISED, also our platinum sponsor by the Swiss Confederation, gold sponsor by Oil Palm Plantation Fund Management Agency, silver sponsor by Swedish Energy Agency and Business Sweden, and Bukit Asam.
Kita mulai aja, Bu Alma panitia.
Ya, sudah bisa dimulai, Pak.
Oke, terima kasih. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Selamat siang, salam sejahtera untuk kita semua. Alhamdulillah kita dalam kesempatan ini, siang hari ini bisa berkumpul secara virtual dalam acara, salah satu bagian dari acara virtual Indo EBTKE CONEX yang ke-10 tahun ini. Dan siang ini kita memasuki hari keempat dari rangkaian acara. Khususnya siang ini kita berada pada sesi besar, yaitu tentang Indonesia Wind Energy Forum. Perkenalkan, nama saya Endang Kuswandi, saya Sekjen Asosiasi Energi Angin Indonesia, yang saat ini berperan sebagai moderator yang akan memandu acara siang ini. Tak lupa sebelumnya saya sampaikan terima kasih yang sebesar-besarnya kepada seluruh keynote speaker, juga para panelis dan seluruh peserta yang hadir di siang hari ini. Semoga acara ini membawa manfaat dan juga memberikan view terkait dengan perkembangan, potensi, dan juga performance wind power di Indonesia. Adapun agenda acara hari ini, kita memiliki 2 keynote speaker. Yang pertama, saya ucapkan terima kasih juga atas kesediaannya kepada Ibu Noneng Omaraningsih, SEMAP. Beliau adalah Kepala Dinas Penanaman Modal dan Pelayanan Terpadu 1 Pintu Provinsi Jawa Barat. Ya, insya Allah pada siang hari ini akan menyampaikan terkait dengan peraturan Presiden yang baru saja terbit, yaitu nomor 87 tahun 2021 terkait dengan percepatan pembangunan di kawasan Rebana dan juga Jawa Barat bagian selatan. Yang salah satunya di sana disampaikan terkait dengan prioritas pengembangan energi angin atau PLTB, pembangkit listrik tenaga bayu. Kemudian keynote speaker yang kedua, selamat datang Pak Agung Hermawan, Ketua Umum Asosiasi Energi Angin Indonesia, yang akan menyampaikan terkait dengan Indonesia Wind Energy Updates serta industri prospektif oleh Pak Ketum. Nah, selanjutnya kami akan lanjut kepada 2 sesi diskusi, yaitu sesi diskusi panel yang pertama yang akan menghadirkan 3 panelis. Kemudian akan dilanjut nanti selesai 3 panelis ini, kita akan ada Q&A session selama 30 menit. Diinfokan kepada seluruh keynote speaker dan panelis bahwa masing-masing waktu yang diberikan untuk setiap speaker dan panelis adalah 15 menit. Selesai 3 panelis, baru kita akan buka diskusi dengan waktu atau durasi selama 30 menit. Itu adalah rangkaian sesi pertama. Selanjutnya nanti akan masuk pada panel diskusi yang kedua yang akan dipandu oleh kolega saya, Pak Ifnaldi. Beliau adalah Wakil Ketua Umum Asosiasi Energi Angin Indonesia, yang juga akan terdiri dari 3 panelis yang akan menyampaikan paparannya. Baik, untuk mempersingkat waktu, pertama-tama kita sama-sama dengarkan paparan atau keynote speech dari Ketua Umum Asosiasi Energi Angin Indonesia, Bapak Agung Hermawan. Waktu kami persilakan Pak Agung. Terima kasih.
Terima kasih Pak Endang. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Selamat datang para peserta Zoom virtual EBTKE CONEX hari ini. Terutama saya ucapkan terima kasih kepada sahabat saya, Ibu Noneng Koswara, yang mewakili nanti yang bersedia memberikan pemaparan khususnya Perpres yang baru-baru ini ditandatangani untuk wilayah Provinsi Jabar. Nanti saya harapkan dari mereka atau pemakilnya. Dan yang saya hormati, terima kasih sebesar-besarnya anggota Dewan yang terhormat, Ibu Diah, Mbak Diah, sahabat saya dari Komisi 7. Kebetulan komisi yang membawahi kita semua ini. Kita banyak berharap banyak dari Ibu untuk menyuarakan suara kita kepada pemerintah maupun kepada hal-hal yang lain. Ibu Diah ini dari fraksi PKS, baru jadi lagi segar-segarnya dan semangat untuk membela EBTKE ini sekali ini. Teman-teman panitia maupun masyarakat energi terbarukan Indonesia yang saya hormati, terima kasih sudah bisa mengarrange acara yang sebaik ini. Mudah-mudahan nanti kita bisa ikuti dan minta kita follow up. Yang paling susah memfollow up, kalau mengikutinya aja gampang, menandatangani gampang, tapi follow up-nya ini susah nih. Jadi mudah-mudahan kita bisa jalankan bersama. Pak Lars, Pak Hans, sahabat saya, mohon maaf, I will convey my speech in bahasa, but my slide in English, and we can discuss later after this conversation ya. Saya akan, silakan di slide saya ditayangkan, tapi saya akan berbicara di luar slide dulu, karena ini saya mau menyoroti highlight 3 bulan terakhir ini, di mana pergerakan EBT itu sangat signifikan. Yang pertama adalah kunjungan atau acara resmi Presiden kita, Pak Jokowi, di G20 Summit dan di COP26 di Glasgow. Ini merupakan suatu kehormatan ya kita di sana. Terus saya juga mengikuti hari demi hari kegiatan COP26. Memang Indonesia diharapkan sekali sebagai paru-paru dunia, sebagai jantung dunia ini untuk menyelamatkan dunia dengan zero carbon emisi. Tapi saya menyambut baik juga delegasi Indonesia yang sudah berinisiatif juga bahwa memang Indonesia bisa menyelamatkan dunia ini, tapi tentunya dengan bantuan seluruh penduduk dunia. Jadi tidak hanya Indonesia, kalau kita Indonesia saja, saya yakin tidak mampu untuk itu, tapi kita perlu pendanaan, kita perlu teknologi dari semua negara. Jadi saya setuju dengan apa pernyataan Pak Jokowi, kalau cuma statement bauran-bauran itu gampang saya lakukan, tapi negara lain juga tidak melakukan itu gitu. Jadi tapi mudah-mudahan Indonesia tidak begitu, tapi tentunya dengan dukungan dunia. Jadi kalau secara teknologi, secara dana kita mungkin berkurang, tapi dengan teknologi dunia, mari kita bersama-sama menyelamatkan dunia kita ini melalui Indonesia tentunya. Dan sangat membanggakan Pak Presiden kita ini akan menjadi ketua di G-Summit selanjutnya. Dan mungkin akan diadakan April atau Maret itu di Pulau Bali ya. Jadi mari kita bersama-sama support itu, dukung itu. Dalam waktu beberapa bulan ini kita buktikan percepatan-percepatan yang akan kita bisa lakukan di sektor kita masing-masing dan apa yang kita mampu kerjakan. Dan saya menyambut baik juga Presiden kita ini kembali dari kegiatan itu, langsung memanggil Board Direction PLN dan Pertamina untuk benar-benar fokus di EBT, jadi tidak hanya di kertas dan sebagainya, tapi itu tidak fokus. Jadi harap fokus, dan kalau tidak bisa fokus, ya siap-siap menyingkir saja, katanya begitu Presidennya. Jadi kita sokong nih, Presiden kita sangat komit dengan EBT-nya, mudah-mudahan diberikan kesehatan selanjutnya untuk bisa merealisasikan dalam kepemimpinan beliau di Summit selanjutnya. Dan update terakhir adalah tanggal 22 Senin kemarin, jadi dibuka, acara kita dibuka oleh Presiden Republik Indonesia, offline dan online. Jadi offline langsung dari istana, dan online diumumkan ke semuanya. Jadi itu cukup membanggakan ya untuk kali ini, komitmen dari pemerintah untuk mendukung kita. Mudah-mudahan ini diikuti oleh semua jajaran di bawah beliau. Dan dalam pertemuan itu juga, METI juga diminta untuk support kita menerbitkan rancangan undang-undang ya, atau undang-undang EBT yang kita rindukan, sudah lama sih kita rindukan, nanti mungkin akan berhubungan langsung dengan Komisi 7 dengan Ibu yang terhormat, Ibu anggota Dewan terhormat, Bu Diah. Nanti rancangan undang-undang kita sudah susun. Ibu ini kalau bicara rancangan undang-undang, saya kita mungkin udah capek rancangan terus gitu ya. Jadi nggak jadi-jadi undang-undang. Mudah-mudahan dengan dukungan Ibu ini nanti undang-undang kita EBT sehingga posisi EBT itu menjadi kuat. Kita ada undang-undang sendiri untuk EBT ini. Jadi mari kita bersama-sama, dan kami dari METI kita akan berkumpul minggu depan untuk memfinalisasikan. Memang udah final, udah lama nih, tapi belum diketok-ketok. Jadi mudah-mudahan minggu depan kita akan ada finalisasi dari kami sehingga draft yang final sudah bisa kita sampaikan ke Presiden maupun ke nanti anggota Dewan. Selanjutnya Ibu, ini ada percepatan juga yang sudah dilakukan di Provinsi Jabar. Jadi udah ditandatangan Perpres, saya lupa nanti Bu Noneng atau teman-teman dari DPMP TSP Provinsi Jawa Barat yang akan menjelaskan bahwa sudah ditandatangan Perpres untuk kalau tidak intinya adalah development ya, percepatan pengembangan proyek-proyek atau Jabar bagian selatan. Jadi nanti mungkin itu bisa dijelaskan lebih lengkap dari teman-teman dari DPMP TSP provinsi. Jadi pemerintah pun sekarang udah mensupport dengan perpresnya sudah turun dan sebagainya. Jadi mudah-mudahan ini bisa direalisasikan dengan teman-teman nih, pengusaha, pengembang maupun teman-teman dari luar yang bisa mensupport kita. Dan tidak lupa adalah RUPTL yang sudah diterbitkan oleh PLN. Jadi terima kasih, kita ucapkan akhirnya RUPTL yang kita namakan RUPTL Green itu kemarin sudah di publik gitu kan. Terima kasih sekali. Ini juga impian kita udah 2 tahun tidak keluar-keluar, dan keluarnya Green karena majority dari sumber energinya adalah EBT. Jadi itu yang jadi pemerintah kita Indonesia ini udah sangat tanggap terhadap itu, dan mudah-mudahan bisa dilaksanakan. Walaupun, nah ini ada walaupun catatan. Jadi positifnya memang EBT semakin besar baurannya dan dipercepat, tapi memang kami dari dari sektor ketenaga listrikan untuk wind dari angin masih agak kecewa karena jauh dari apa yang dirancang gitu ya. Jadi dirancangnya dulu kita sama-sama dengan PLTS dengan solar, kita separuh-separuh 2 giga, solar naik jadi 4 giga, anginnya kok hilang gitu. Walaupun anginnya hilang. Jadi nanti mungkin Ibu anggota Dewan juga bisa ini, karena kalau kami berargumentasi mengenai energi angin sangat efektif, Ibu. Jadi Bapak-Bapak sekalian, jadi waktu kita peresmian Sidrap ya, kita banggakan juga UPC, teman-teman UPC Sidrap, itu mungkin baru pertama kali ada pembangkitan tenaga listrik yang diresmikan oleh Presiden, tapi berbaur dengan masyarakat. Karena memang kita tidak merusak lingkungan, gitu. Jadi namanya angin itu tidak menutup lahan, ya kan? Saat 4 mega itu cuman hanya makan tempat 20 kali 20 meter persegi, jadi tidak banyak. Dan baru kali itu jadi Presiden berbaur dengan masyarakat, tidak ada batasan-batasan. Kalau di pembangkit tenaga batu bara kan ditutup, malah kalau kita berhenti di depan pagar luar jalan aja satpamnya sudah datang mencurigakan. Tapi kalau di kita hanya turbinnya aja nggak boleh naik, tapi itu bersatu dengan masyarakat. Jadi mudah-mudahan tower-tower wind turbine ini makin banyak dibuat di Indonesia ini, gitu. Jadi makin banyak di Indonesia, makin banyak ini dan berbaur dengan masyarakat. Itu harapan saya, itu highlight yang saya catat dari 3 bulan terakhir. Bagi teman-teman, bagi anggota yang masih belum puas kita dengan kuota kita, sabar ya. Karena kalau kita bandingkan dengan teman kita di PLTS, besok dia mau bangun pembangkit tenaga listrik, tenaga solar, dia langsung bisa bangun. Kalau kita harus mengukur. Kalau kita harus mengukur 1 tahun, 2 tahun, pakai kantong dari kita, dari biaya kita sendiri, pemerintah belum ikut campur di situ. Jadi mudah-mudahan kita tetap semangat bahwa memang yang penting arah dan tujuan kita sudah benar. Jadi tinggal Gusti Allah aja yang meresetui, dan nanti melalui Pak Jokowi dan Pak Menteri, Pak Arifin Tasrif, maupun teman-teman anggota Dewan yang bisa lebih merealisasikan apa yang menjadi impian kita bersama. Jadi tetap semangat, jangan putus asa, langkah kita bersama sudah benar arahnya. Jadi kalau kita lihat di Eropa, itu kita jalan dari Belanda, Belgia, Jerman, dan sebagainya, itu kincir angin sudah di mana-mana. Harusnya itu bisa juga dibangun di Jawa bagian selatan sampai ke Bali. Jadi menurut saya, jangan menyerah, kita jalan terus, jangan putus asa, ukur terus angin di mana-mana. Saya yakin 2022 akan berubah, nanti dengan bantuan teman-teman di anggota Dewan yang terhormat, kita bangun sebanyak-banyaknya tower turbin angin yang sebesar-besarnya ada di sini. Selanjutnya mungkin slide saya bisa di-share. Jadi saya itu bicara highlight, mudah-mudahan kalau kata profesor saya, kalau slide itu bisa dibaca nanti di rumah, tapi kalau langsung profesor bicara, ya kan, itu lebih penting. Silakan. Tapi ini teman-teman disusun oleh teman-teman dari ini. Silakan di-share slide saya. Panitia.
Bapak maaf, koordinasinya kata Pak Isnaldi, Bapak akan nge-share sendiri, Pak.
Ditolong aja bisa ada.
Oke, saya.
Ibunya bisa share, Pak Ib. Silakan.
Ya, jadi kira-kira di slide saya akan membicarakan beberapa hal. Jadi pertama, member kita saat ini sudah 17. Selanjutnya juga saya mengutip dari teman-teman, juga mengutip beberapa perkembangan yang sudah terjadi di EBTKE maupun sampai saat ini. Jadi mungkin buat Ibu di anggota Dewan maupun di teman-teman, kita dari tahun 2017 tidak ada lagi PPA, ya 2017 ya, tidak ada PPA lagi, sampai saat ini kita mudah-mudahan maka itu dengan kegiatan EBTKE ini akan ada tanda tangan PPA di tahun-tahun selanjutnya. Gitu. Mudah-mudahan seperti itu. Gitu. Bisa Pak Ib?
Pak, nggak bisa Pak, no.
Oke.
Pak Aduh, dikirim ke alamatnya bisa nggak ya? Yang terakhir tadi Pak Bung.
Iya.
Bisa Pak, silakan.
Bisa di-share?
Yang mana tadi?
Bisa Pak Sekjen, bisa?
Beda laptop ini tadi. Pak Ketua mau langsung share sendiri, coba.
Saya kirim ke Alma aja ya, Alma bisa nggak ya? Yang
Bu Alma aja yang share ya?
Ya, biar saya ada Pak, dikirimkan boleh.
Ya, jadi saya lanjut saja. Saya baca dari laptop saya. Di WA saya terakhir, Pak Endang, Pak If, udah saya minta di-share dari panitia. Oke, kira-kira kita membership kita, Wind Energy itu terdiri dari ada para developer wind energy, terus komponen maupun manufacturing, kontraktor, ya, terus IPP dan sebagainya. Itu member-member kita. Sampai saat ini tercatat ada 17 member, ya, yang terdiri ada dari pabrikan dan sebagainya, developer dan sebagainya. Jadi itu karena angin memang juga wilayahnya terbatas, sini terbatas, jadi anggota kita juga tidak banyak. Tapi anggota banyak aja, PPA-nya juga dikit. Jadi sebenarnya presentasinya juga bagus juga, jadi 2 dibandingin 17. Gitu. Jadi mudah-mudahan, tapi dengan dan jangan lupa kita Asosiasi Energi Angin ini juga tidak mengurus masalah yang besar-besar juga, tapi kita juga mengurus hal yang kecil-kecil. Saya terima kasih kepada sahabat saya dari Highwind Energy Solution maupun dari Pondera yang telah membuat suatu program hybrid ya di tempat diklat kita energi angin kita yang ada di Lembang, di Bandung. Kita saat ini sampai tanggal 1 nanti kita sekarang sedang mengadakan pelatihan untuk guru-guru SMK dari Kupang untuk kita siapkan untuk menjadi operator tenaga nanti di daerahnya masing-masing. Jadi kita lakukan. Jadi tidak hanya yang skala besar, kita juga skala kecil kita kembangkan. Nah, selanjutnya kita bisa lihat bahwa government effort untuk kita di angin juga sudah ada, sudah di INDO sudah ada, walaupun memang tadi saya katakan belum begitu memuaskan kita semua. Jadi mudah-mudahan usaha kita bersama ini bisa menjadi lebih besar. Potensi angin di Indonesia itu yang tercatat di kami untuk onshore dengan kecepatan 6 meter per sekon ke atas itu kira-kira 15 gigawatt untuk onshore. Kalau untuk di 4 meter per sekon ke atas itu kira-kira 60 gigawatt itu potensi kita. Nanti mungkin di-share belakangan itunya ya, slide-nya. Terus offshore-nya kita ada 107 gigawatt untuk offshore karena memang besar 6 meter per sekon. Tapi informasi yang terakhir bahwa memang tata ruang untuk offshore di Indonesia sedang dipersiapkan oleh Kementerian Maritim. Jadi mungkin mudah-mudahan di 2022 selanjutnya itu sudah publish ya. Terus yang keinstall baru 149 megawatt sampai saat ini di kuartal keempat tahun 2021, 149 megawatt, di mana yang ber-PPA itu 130 megawatt. Sumbangan 130 megawatt itu, itu dari Sidrap dan Jeneponto, Sidrap UPC dan Jeneponto Vena menyumbang 75 megawatt dan 72 megawatt. Small scale non komersial itu ada 2 megawatt untuk angin. Konstruksi pada saat ini tidak ada sama sekali konstruksi. Untuk PPA juga tidak ada sejak tahun 2017, mandul kita. Ya mudah-mudahan ini bisa 2022 katanya akan dimulai tender-tender PLN, karena memang sejak 2017 perubahan regulasi, semua tender melalui PLN, jadi kita menunggu tender PLN. Jadi mudah-mudahan dengan instruksi Presiden kepada pimpinan PLN dan teman-teman di PLN ya, harap mungkin tendernya bisa dipercepat. Tender 2021 masih pending, beberapa tender waktu itu ada 2001 pending, yaitu PLTB Timor, jadi mungkin nanti 2022 Timor akan mulai tender. Wind project di RUPTL. Di RUPTL ada 595 megawatt dan plus PLTB tersebar. Jadi kita ada 595 megawatt. Terus kalau yang diukur, potensi terukur, kita sudah 3 gigawatt yang terukur. Jadi memang tinggal menunggu tender PLN. Kalau dari sisi teknis dan sisi pengukuran, administrasi kita udah siap, peserta-peserta juga udah siap. Jadi tinggal PLN membuka tender itu, dan menurut saya kita sudah siap untuk mengikuti tender. Targetnya 1,8 gigawatt sampai tahun 2025 kita. Terus 28 gigawatt sampai tahun 2050 kita bisa sumbang dari sisi ke energi. Langsung ke slide 11, Mbak. Terima kasih. Langsung ke slide 11 ya.
Waktunya 5 menit lagi, Pak Agung.
Oke. Slide 11. Nanti kita share ya ini. Slide 11, Pak. Ya, jadi tadi saya kasih tahu inforkan bahwa potensi dari offshore 2021 yang kita terima di asosiasi adalah 60 gigawatt onshore dan 107 gigawatt offshore. Jadi tersebar di beberapa wilayah. Ya mungkin nanti jadi saya rasa sungguh besar, dan kembali lagi tadi kalau kita wind farm itu lebih bersahabat, kita tidak menutup banyak lahan, ya kan? Jadi terus bisa juga sebagai tempat wisata, karena beberapa hal di Eropa saya sudah kunjungi itu kebanyakan itu dipakai untuk tempat wisata. Jadi sangat baik dari beberapa hal lah untuk ini. Selanjutnya, Pak. Nah, ini wind speed ya, yang sudah resmi dikeluarkan, bisa kita dapetin semua. Ini kalau nggak salah dulu kerjasama dengan Denida ya, dari Denmark ya, Pak If ya. Mungkin ini publish, bisa didapatkan oleh semuanya. Semuanya. Mudah-mudahan ini bisa ini bisa juga membantu para developer maupun para investor yang menarik, karena banyak potensi-potensi angin di negara kita yang bisa dikembangkan. Dan ini publish, bisa didapat di mana, di website resminya. Itu ada beberapa, ada Indonesia Wind Prospecting dan sebagainya. Mungkin bisa di ini. Lanjut deh. Nah, ini proses fit and tarif ya, yang kita usulkan waktu itu. Ada beberapa kali kita usulkan. Mudah-mudahan nanti dengan regulasi dan sebagainya, permen yang baru ini karena kalau saat ini kita masih pakai peraturan Menteri SDM nomor 4 tahun 2020, based on BPP. Kita mengharapkan ada presiden regulation atau tentang renewable energy. Kita mengusulkan dari Asosiasi Angin mengusulkan hal yang ada di slide, kita sudah sampaikan. Jadi mudah-mudahan kalau ini bisa kita dapatkan, saya rasa energi angin ini akan menjadi lebih menarik, Hanya kita memang kami juga ngelihat bahwa perkembangan terakhir ini, kalau nggak salah saya dapat informasi dari pabrikan turbin angin, itu investasi untuk turbin itu turun sampai 50-60%. Jadi sekarang teknologinya juga murah gitu, udah nggak seperti dulu gitu ya. Mungkin saat ini.
And it is cheaper than a long time ago.
Teknologi juga semakin murah.
And I think because of the technology is cheaper too, so the cost will be decreased.
Dengan tarifnya juga terbatas, maka itu saya dengar dari Wamenku, dari Menteri Keuangan, Profesor Swa juga menyiapkan satu skema ya, ada
we have prepared
menutup gap itu. Jadi mudah-mudahan nih. Nah, hasil dari Glasgow yang
to
kemarin,
solve the gap based on the Glasgow conference. Hopefully, the other countries can also solve the problems, include Indonesia. And hopefully Indonesia can be a good country as the lung of the world. And hopefully the gap can be fulfilled by another countries. So the president instruction can be implemented well.
Menit katanya ya?
Oh, berapa ditambah Pak, 5 menit Pak? Karena slide yang penting Pak. Ya.
Jadi tadi info juga dari Glasgow, kebetulan sahabat saya Profesor Swa gitu, memberikan masukan juga bahwa memang inilah yang pemerintah cari gitu. Jadi mungkin kita perlu bantuan dari luar dan sebagainya untuk menutupin gap itu. Karena Indonesia punya keterbatasan membeli listrik itu, PLN punya keterbatasan membeli listrik itu. Dan kita sebagai pengembang juga bukan sinterklas, ada juga keterbatasan. Saya yakin pengembang-pengembang ini baik-baiklah, tidak mengembang, apalagi anggota saya tidak langsung harus mahal, tidak. Bisa murah dia akan murah, tapi tentunya pasti masih lebih di atas gap itu. Nah, walaupun kalau kita bandingin sama pembangkit listrik tenaga batu bara, kalau dilihat dampak lingkungannya, kita hampir dikatakan tidak banyak berdampak gitu. Jadi menurut saya itu juga kalau dibandingkan kita bisa lebih itulah.
Mohon maaf Agung, waktunya sudah habis. Bu Noneng juga sudah siap ya.
Terima kasih. Mudah-mudahan penjelasan saya atau speed saya bisa membantu dan sebagainya dan bisa memajukan energi tenaga angin di Indonesia. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Terima kasih Pak Agung, Ketua Umum Asosiasi Energi Angin. Sebelum kita lanjut ke keynote speaker yang kedua, nanti ada sesi panel setelah ini yang menghadirkan para pembicara. We like to welcome to Mr. Eric Arends, Vice President Pondera Consult Southeast Asia, and also Mr. Lars van der Lid, Business Development Executive from Hexicon, and also we'd like to welcome to Arka Wiryajaya, Market Development Director from GE. Bu Noneng sudah siap?
Ya, Pak.
Selanjutnya kita sama-sama simak dan mendengarkan paparan dari keynote speaker kedua, Ibu Noneng Komaraningsih sebagai Ibu Kepala Dinas Penanaman Modal dan Pelayanan Terpadu Satu Pintu Provinsi Jawa Barat. Sebelumnya kami ucapkan selamat ke Ibu Noneng atas terpilihnya Jawa Barat yang memperoleh Perpres Bu ya 87 nomor 2000 tahun 2021. Congratulations Bu for the very good achievement, especially for acceleration of the renewable energy development, especially in southern part of West Java Province. Ya Pak, silakan Bu, waktu dan tempat kami persilakan ke Bu Noneng. Terima kasih.
Baik, terima kasih. Assalamualaikum warahmatullahi wabarakatuh. Selamat siang, salam sejahtera buat kita semua. Sampurasun. Terima kasih atas undangannya. Mungkin saya juga supaya untuk efektif waktu ya, kita akan langsung melihat bagaimana Perpres ini, karena bagaimanapun juga ini sebagai penguat dari sisi regulasi terhadap pembangunan yang kami rencanakan, baik di Jabar sebelah utara, timur, dan juga Jabar Selatan. Ini merupakan program kami bagaimana menghasilkan investasi juara yang salah satunya juga untuk menghilangkan kesenjangan antar wilayah dan tentu saja juga percepatan pembangunan di Jawa Barat untuk kesejahteraan masyarakat Jawa Barat. Kita akan melihat paparan ini mungkin 15 menit ya? 15 menit,
ya, Bu, 15 menit
bagaimana mengenai Perpres, kemudian program infrastruktur energi dalam Perpres, kemudian program infrastruktur energi di kawasan Rebana di Jabar Selatan, dan juga pembangunan PLTB di Jabar Selatan. Karena kami juga sangat concern terhadap climate change, terhadap lingkungan hidup. Baik, kita mulai. Urgensi dari Perpres itu sebetulnya ada 5 hal paling tidak. Pertumbuhan investasi dan peningkatan perekonomian nasional yang terintegrasi, kemudian mendukung dan melengkapi instrumen percepatan pembangunan ekonomi di Pulau Jawa, khususnya di Provinsi Jawa Barat. Kami sudah melakukan pertemuan-pertemuan dengan seluruh kementerian yang terkait, karena nanti di kawasan ini juga menjadi disetarakan dengan PSN, begitu urgensinya ya dalam seluruh proyek yang ada di 2 kawasan ini berdasarkan Perpres 87/2021 ini. Sebagai penerjemah langkah-langkah strategis dan terintegrasi atas arah pembangunan yang jelas, strategi yang tepat, fokus, dan terukur. Kita sudah mapping seluruh proyek yang ada di Perpres ini. Nanti kita lihat masing-masingnya, dan juga sudah dibicarakan mana yang masuk APBN, APBD, ataupun yang memerlukan investasi dari pihak investor swasta ataupun BUMN-BUMD. Memperkuat legitimasi pelaksanaan implementasi program pembangunan kawasan metropolitan dan pusat-pusat pertumbuhan Jawa Barat. Dengan adanya Perpres ini, tentu saja memperkuat dari sisi regulasi, sehingga meyakinkan buat para investor semua bahwa Rebana Jabar Selatan itu merupakan satu kawasan strategi investasi yang didorong oleh pusat dan daerah. Kemudian memperkuat landasan hukum investasi pembangunan kawasan metropolitan dan pusat-pusat pertumbuhan Jawa Barat. Dan kemarin Perpresnya sudah ditandatangani serta sudah kami terima, dan secara simbolis kita juga terimakan pada saat West Java Investment Summit, supaya juga diketahui oleh seluruh dunia, karena West Java Investment Summit kemarin juga diikuti oleh banyak negara. Kemudian tujuan dari Perpres tersebut adalah penyediaan infrastruktur dan peningkatan investasi yang bertambah pada regional dan nasional. Bagi investasi sendiri, dengan adanya infrastruktur ini, para investor tentunya juga lebih percaya dan lebih yakin bahwa kawasan yang kami bangun ini dipersiapkan, terutama infrastruktur dasar, baik di Rebana maupun di Jabar Selatan, sesuai dengan rencana induk pembangunan di kawasan tersebut. Kemudian kalau melihat muatan batang tubuh dari Perpres ini, selain tujuan tentu saja ada lingkup wilayah, lingkup substansi, fungsi rencana induk. Nah, ada ketentuan PSN dalam Perpres, karena PSN tentunya juga berbeda perlakuannya, termasuk di dalam perizinan OSS dan sebagainya. Kemudian dukungan kementerian, lembaga, dan Pemda, kemudian kerjasama dengan pihak ketiga. Pasal 8 menyebutkan sumber pendanaan, kemudian pasal 9 menyebutkan pengawasan rencana induk, dan pasal 10 tugas KPPIP, kemudian pasal 11 ada ketentuan perubahan, penyesuaian, serta pemberlakuan Perpres. Nah, keunggulan PSN ini di pasal 5 itu menyebutkan bahwa ketentuan peraturan perundang-undangan yang mengatur mengenai proyek strategis nasional berlaku bagi peraturan presiden ini. Jadi pasal ini tentu saja jadinya menyebabkan pengaturan terhadap proyek-proyek yang ada lebih strategis dan lebih diutamakan, seperti itu. Contohnya percepatan perizinan berusaha bagi kegiatan usaha yang termasuk dalam risiko tinggi dalam PSN. Kemudian juga fasilitas penyelesaian permasalahan dalam perizinan berusaha dan pengadaan tanah. Itu untuk PSN, itu beberapa contoh privilege apabila proyeknya termasuk ke dalam PSN. Kemudian kalau melihat gambaran umum kawasan Rebana dan Jawa Barat bagian selatan ini secara umum ya, bahwa di Rebana ini jumlah total penduduk 20% dari total penduduk Jabar, kemudian mempunyai nilai total PDB 199 miliar rupiah. Presentasi penduduk miskin ini lebih tinggi dari rata-rata Jawa Barat ya, 11%. Laju pertumbuhan ekonominya minus 0,72, kemudian IPM juga di posisi yang rendah gitu.
Quite low, and then there are a lot of poverty, and the economic growth is still minus. And we hope that this development will make a better future for this area. And we also still take care about the condition of the environment, especially about the resources. And we hope that the investment will be increased too.
sekitar 234 triliun ya. Kawasan rebana 200 memerlukan pendanaan 234 triliun yang tadi saya sampaikan bisa.
And this is the fund
investasi dengan total program sebanyak
that
41 program.
we need for the development around 392 trillions rupiahs.
Kemudian kalau kita melihat rencana induk pengembangan
And based on the planning in Rebana,
seperti ini. Jadi rencana induk penyediaan dan peningkatan infrastruktur transportasi.
we want to build some infrastructure first, especially the road, and then the facilities
penyediaan dan peningkatan infrastruktur perhubungan. Jadi rincinya
about
tadi yang berapa? 8
waterways and another ways.
dan 89 program di Jabar Selatan. Kalau dirinci ini seperti ini.
And we also want to anticipate about the flood. And we hope that this will make a good impact for the human resource development too. And we also concerned about the fishery and other business, and also about the tourism itself.
Waktunya maaf Bu, 5 menit lagi Bu ya.
Oke, ya.
Langsung ke angin. Ya.
Oke.
Mungkin bisa ini Bu ke highlight yang PLTB Selatan itu Bu.
Oke. Nah, ini mungkin pengembangan kawasan di Rebana ya, ada cukup banyak pengembangan kawasannya. Itu bisa dilihat. Saya sekalian juga ingin memperkenalkan konsepnya bahwa
And I would like to introduce the concept for Rebana, the integration of live, work, and play based on 3 core points.
Bahan paparan ini supaya juga Bapak Ibu sekalian mungkin bisa melihat bahwa untuk renewable energy itu juga di beberapa
And the renewable energy will be developed more in this Southwest Java, South area in West Java.
Sendiri di Jabar Selatan ada 8 program, tapi kemudian
and there are 8 programs about the renewable resources.
Slide-nya diloncat aja mungkin ya. PLTB.
Oke, nah ini semua programnya, tetapi mungkin kita loncat ke paling nah ini.
Ya, ini
jadi ada 2 project ya.
There are 2 projects about the wind energy. First, the wind energy in Garut. West Java, and it needs about 500 until 800 million rupiahs for the funding, and this is the turbine reference in Ciamas, Sukabumi, West Java, and total investment is about 3.3 trillion rupiahs.
Investasi 500 sampai 800 juta US dollar dan lokasinya berada di Garut, Jawa Barat. Barangkali itu yang bisa
that's all from me.
Mohon maaf agak tergesa-gesa. Terima
Thank you very much.
Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Terima kasih yang sebesar-besarnya untuk Bu Noneng yang telah menyampaikan paparan terkait dengan Peraturan Presiden Nomor 87 Tahun 2021, khususnya tadi di bagian terakhir terkait dengan percepatan pembangunan Jawa Barat bagian selatan, yang mana diantaranya ada rencana pengembangan PLTB atau wind farm di Kabupaten Garut dan Kabupaten Sukabumi, yang mudah-mudahan dengan Perpres ini bisa mendorong cukup signifikan terkait dengan rencana pengadaan PLTB yang tadi seperti Pak Ketua Umum sampaikan, belum ada lagi PPA ya sejak terakhir sekitar 3 tahun yang lalu. Jadi kita nih di wind farm ini ceritanya kuasa PPA sementara ini. Mudah-mudahan dengan adanya Perpres ini diawali di Jawa Barat Selatan, yang mana kapasitas gridnya juga bagus, mendukung, mudah-mudahan ada satu percepatan sesuai dengan apa yang diharapkan dari terbitnya Perpres tersebut. Selanjutnya, terima kasih sekali lagi. Saya sampaikan big applause untuk Bu Noneng dan juga Pak Agung sebagai Ketua Umum Asosiasi Energi Angin, Bu Noneng sebagai Kepala DPM TSP Jawa Barat atas paparan yang telah disampaikan, atas kesediaan waktunya. Insya Allah setelah ini kita akan lanjut dengan sesi pertama. We'd like to inform all speakers, all panelists that we'd like to have a start to the one panel session with the main topic about the potential and demand creation deriving by the energy transition. We are very happy that in this moment we have 3 panelists from around the world that we believe have good experience that we can share to us, especially in Indonesia as a developing country that start to develop wind farm, hopefully not only in onshore but also offshore. That, as you know previously in the slide from chairman of the association, that the potential of the off-grid in Indonesia also good and promising, even though bigger potential in terms of capacity if we compare with the onshore wind farm. In this first panel of discussion, we have here, we like to welcome first panelist is Mr. Eric Arends. He is a partner and vice president of Pondera Consult Southeast Asia. I think we have met before, Mr. Arends in Amsterdam. See you again here. And the second panelist is Mr. Lars van der Liet, business development executive from Hexicon. See you again, Mr. Lars. We have discussed a couple months ago.
Yes, we did.
And also, yeah, and also the latest panelist, but not least in this first session, is my friends, Mr. Arka Wirya Dijaya, a young man. He's a market development director from General Electric. So, as I explained before in the first session, that we will have you to present your material, 15 minutes for each speaker, for each panelist, and then to the audience, if you have any questions.
Telah disediakan waktu sebanyak 30 menit untuk masing-masing pembicara.
You can raise your hands and or chat to the mailbox, the chat box. Okay, for the first speaker, welcome to Mr. Eric Arends. The time is yours, please.
Thank you very much. Thank you very much, dear ladies and gentlemen, good day to all of you. Thank you for inviting me to contribute to this important Congress. I feel very honored to be able to do so. I would like to tell you something about experience in Europe, compare with where we are now in Indonesia. And for that, I've prepared some slides. I will share my screen with you. go up to the first slide and presentation mode. One moment. Hopefully you can see it full screen right now.
Yes.
Yes. Okay. Well, the session about potential in demand creation, driving by energy transition, I would like especially go into.
Excuse me, Mr. Ernst, can you?
Yes.
This is not full screen yet. Can you maybe click the full screen?
Does it work?
Not yet. Usually in the corner bottom or in the upper bottom. This is still two slides here appear in the screens. Yeah.
Oh yeah.
Yeah.
Let's see. You see the presentation slides of me right now.
Yeah.
Maybe does this help?
Not yet. But it's readable. I think it's no problem. You can continue. You can still clearly to see what. Yeah.
Yeah, you can see the next slides as well. I think.
Yeah, yeah.
Oh yeah. It's okay. Thank you.
Okay. Yeah.
Okay. Well, it's you can see what's coming next then. Well, I would like to say something about the contribution of offshore wind to the wind energy development in Indonesia. After introduction, I will say something about the policy and the potential. Go into the question I would like to answer in my presentation, and then make some comparison with the development in Europe and see what we can learn from that. First of all, very shortly about Pondera. We are specialists in renewable energy. We're consultants, engineers, and also investors. We develop and co-develop projects ourselves as well. We have offices in the Netherlands, where we are based with a headquarters, and also have offices in South Korea, Indonesia, and setting up in Vietnam right now. Indonesia, I would especially like to mention Chanda Sumitro as director of Pondera Southeast Asia. We are, you could say, a medium-sized group of companies with 70 employees dedicated to renewable energy, and a lot of companies we work closely together with, which counts to hundreds of specialists that are available. As said, my name is Erik Arends, managing partner and vice president of the Pondera group of companies. This wheel reflects the life cycle of projects. We can deliver services to all phases of projects, and we are especially well known for the first phases of the development of projects and helping all others to develop their projects as well. And that is something we are doing right now in Indonesia as well. We have several projects in different stages of development at the moment. Well, that's enough about Pondera. Let's take a short look at the energy policy and offshore wind energy potential in Indonesia. It is already presented before I started, so I will take a short look at it. If you look at Indonesia's energy mix, you see that especially fossil fuels and especially coal makes a large contribution to the power generation, and even a growing contribution to the power generation. And the share of renewables is only at 5.8% right now, if you take the traditional bioenergy apart from this. So Indonesia is starting up, but there are challenges, as you can see. If you look at the renewable energy policy, there are quite ambitious targets set with greenhouse reductions of 29% in 2030 and renewable energy production of 23%.
Dampak dari emisi itu sendiri sekitar 29% pada tahun 2030.
Too explicitly mentioned in policy, but is considered to be 1.8 gigawatts by 2025. And we are now at 150 megawatts, a bit more than that. So that is a large step to take in a few years of time. So a great challenge, I think. If you look at the capacity of renewable energy, and especially wind energy, it is not so very certain what to expect there. You see different studies about what is available in potential of wind energy. Here, for example, you see in the last column 9.3 gigawatts for onshore wind energy. But IRENA, the International Renewable Energy Agency, placed a disclaimer to this study that there is a lot more probably available. And that is also what you see if you look at recent publications of the World Bank. They count to 81 floating and more than 200 fixed bottom for offshore wind generation. So counting in a total of more than 280 gigawatts. Well, probably it is somewhere in between, and there is a lot available with regard to offshore wind to contribute to the renewable energy power generation in Indonesia. If you take a look at the wind speeds and the potential, you see especially in the eastern part of the country a huge potential with shallow waters relatively and high wind speeds. But if you take a close look at the map, you also see other areas that are quite interesting and are waiting to be developed in the future. We just had Glasgow COP26, and the targets became even more ambitious, and especially turning away from coal, and that is one of the main sources of power in Indonesia, is very important, I think, to really make progress in renewables. Well, what question would I like to answer in this presentation? The question was, to what extent is supply and demand for wind energy driven by the energy transition? Well, if you look at COP26, you see that the energy transition has set ambitious targets. And I think if you look at the possibilities for Indonesia to reach these targets and really produce renewable energy, then wind energy is a source that can really contribute a lot. And the question is, therefore, the question to answer is, how can we achieve a steady development of offshore wind in Indonesia? I think it's an interesting question to take a closer look at. And I would like to do that by looking at the development history of offshore wind in Europe. And I know very well that the situation is not comparable. So I'm really not saying that Europe does it all better and you should try to do it in the same way. But there are some interesting lessons learned from that. So let's take a quick look. You can see 4 different phases we went through in Europe, and it took more than 20 years. So it's not easy to do it that all in a short period of time. But let's go through these phases. It all started, I think, in 2000, and in some countries already a bit earlier, 5 years or so earlier. And what you see was that a growing number of developers looked at opportunities to develop offshore wind energy. And it was a very uncertain development process right then. And what you saw also was that governments did not really know what to ask for in terms of the studies that has to be done, etc. There were no guidelines, governmental guidelines to develop offshore wind. And you could say that during this phase, the rules of the game were drawn up during the game. And we will later see that resembles quite a lot the situation we are in Indonesia right now.
Excuse me, Pak Eric, the time is 5 minutes left.
Okay, no problem. The second phase is first realizations, and here you see that there is a framework, a governmental framework in place, and the first large wind farms were developed. Here you see a picture of the 600 megawatt Gemini project in the Netherlands, for example. And also there was a professionalization of the wind energy sector and of the supply chain. We are now actually in Europe in the upscaling phase, with large areas appointed by the government for offshore wind energy, and even larger wind farms constructed up to 1 gigawatt at a time, and a very steady rollout. And that allows investors to really invest in, as for example, specialized vessels. The next phase not to come, you will see that there are new bottlenecks coming, like shortages in the supply chain, for example. But if you compare that with Indonesia right now, you see that there is no wind farm constructed, no offshore wind farm, but there are quite some developers looking at the opportunities that there are. And I think the last presenter with new policy in place for West Java has taken a good step to enable this development. And of course, I know there are many differences compared to Europe, like lower wind speeds, different soil conditions, different depth. But also there is a good opportunity to develop and use all the developed already technical experience and materials in other parts of the world, like in Europe. So then I come to my final slide right here. If we look at the phases we went through in Europe and we compare it where we stand right now in Indonesia in a very early development phase, I think there are a certain amount of things we should do. We should develop a clear offshore wind policy with solid targets and an action plan for that. We should, and that is very important, I think, create a long-term certainty. So across elections, with a clear target and also clear budgets that are appointed and that are anchored in legislation, so that will survive elections and is stable for many years. An appropriate feed-in tariff or another subsidy scheme is very important, and also to keep that in place for at least, let's say, 7 years, because that long it takes to develop a wind farm offshore. Looking at the risks, allocate them where they can be controlled. So you cannot expect a developer to solve grid connection problems, for example. That is something the government and PLN has to take on, to pick up. The permitting scheme and the way you can obtain a permit and a license to construct a wind farm should be much simpler and preferably more like a one-stop shop. So you should be able to go to one authority and then apply for legislation and get a clear message of what you should study to obtain that. Indonesia is very large. With marine spatial planning and appointing certain areas, I think you can make a good step forward. It is impossible to develop everywhere at the same time in Indonesia. By doing this and by having this stable policy, you support the setting up of a supply chain in Indonesia as well. And for that, I think it is very good to seek close cooperation with international suppliers and encourage that international collaboration, because it is an international market indeed. To show that it is really possible in Indonesia and to show how it could be done, it is important to have some pilot offshore wind farms in place. So I think it's very good, for example, the area that is now appointed to West Java, to look for opportunities there to start with a pilot offshore wind farm. And last but not least, there are some future and current bottlenecks appearing already. Keep a good eye on that, because that can be the challenge for the future. Well, thank you very much. This is what I would like to contribute to this Congress, and I'm very open for any questions. Thank you.
Excellent. Thank you. Thank for Mr. Eric. It was very interesting. If we can now about the 4 stages or phase, starting from the pioneering up to the upscale, lesson learned from Europe experience. Yeah. I believe that there are any question from the audience regarding these stages, which is Indonesia is very early stages. And right now we have already auction or tender system already. Not like in your presentation, it take more than 10 years, I believe, yeah, to starting from the third stage regarding the auction system for the procurement wind farm project. Yeah. Okay, well, and then thank you again to Mr. Ek. The next presentation will be delivered by Mr. Lars van der Dit. Excuse me if I missed the spelling. Business Development Executive from Hexicon. He will present about developing offshore wind power in Indonesia. Mr. Lars, the time is yours.
Okay, thank you very much. I will try to share my screen. So it should come up in a second. So I'll put it on. So can you see it now?
Yeah.
Good. So thank you very much for the invitation. And thank you very much for your introduction, Eric. What I will tell you now is actually fitting perfectly into your presentation. So Hexicon is a company that actually doing what you are aiming for and what Indonesia is aiming for. We started in 2009. We started as a pure technology company, and we are now very much into project development. And my role within Hexicon is actually to do project developments in new markets and go from the very, very early stage and finding out what's possible or not possible. A little bit of my background. I come from the industry, not the wind industry, but I brought up in the finance, IT, telecom, and other things in life. Worked over whole Europe and Asia as well. So I will focus on a little bit what Hexicon is doing. I have picked 3 projects that will fit perfect for Indonesia, and I will draw some conclusions in the end. So Hexicon holds patents, and the patents cover the mooring system, the floating foundation, and also the columns. We work with any type of wind turbine supplier, so we are very agnostic to that. And we are very much present in many markets. We started up in South Korea, and I will tell a little bit more about that later on. We are now also present in Scotland, England, Spain, Sweden, in South Africa and Ireland. The whole idea of today and what we have done so far is to look upon Indonesia as a potential market. And that's where our partnership-based product development comes in. I would say that in all markets so far, we have always hooked up with a local party that knows the regulations, understands the local market. We form joint ventures, and then we move on. I will give an example. We have Shell as part of our development in South Korea. We have Copenhagen Infrastructures as part of what we are doing in Scotland. CONEX is also part of the joint venture in South Korea, and Acciona, I will show you, is part of what we're doing in Spain. So this is what we do. We have a floating platform, we have 2 turbines on it, and we have a very flexible mooring system. Means that the whole system can follow the wind direction. This actually means that it increased the flexibility in the site selection, and also it gives us much higher density. We get absolutely the best wind conditions because we can be very far out from shore. Lower maintenance because we are actually putting all this together in the shipyard or close to shore waters, or we can also do it outside if needed, but that's not the whole idea. And it also lowers the cost of energy production. If you move to the next one, this is a normal project for us. We are scouting for where to be, and we also hook up to the grid. But, and this is what makes it so important and interesting information, we do not need to hook up to the grid. We can also see to that we connect to a company with large consumption or to a local island or whatever needed. One thing that is a keyword is so-called coexistence. And there was a little bit of discussion in the morning about how do we handle fisheries that might be marine life and also some shipping routes. We can handle all these things because we can set our foundations, what is more in the most suitable places. And we start normally where the water depth is about 50 meters. And in Korea, we are about now to do it in 150 plus meters depth. So for us, a normal project will look on all these type of activities. This is not only an offshore wind project, it's also very much a local industrial development project. This is how it started in South Korea. When we started there, we were awarded a feasibility study. That study was done with the thought of having a farm outside the city of Busan. We then went to an industrial exhibition, and then immediately was asked by the city of Ulsan to come and present our ideas. After a couple of months, we were awarded the first water areas to start developing this site. Of these sites now, because we got more and more areas. And this is the beauty of the beast. We do not need to do all the things out at shore, which makes the risk higher and the difficulties with water and wind conditions much more focused. And this is what we really are focusing on. And what I'm definitely focusing the first one is to find the right place to be in. And I was part of starting up in Korea. I have since the last 2 years been working in Sweden on, I would say from the very first idea. Erik talked about the Europe development sites. Yes, he's right. It has been a long developing period. I took this information and I went to Sweden. I went to all the stakeholders that were interested in this under the radar, and we are now together with Aker Offshore Wind developing a full-scale wind farm in different sites. It's a permitting, and it's about the time it takes to get permits that actually predecess this curve. So if this is done right, we can actually take down the project development phase from about 8 years down to a couple of years if we have the right authority to talk to, and if there are waters designated for these activities. This you have seen, and you have provided it to me. There are many places where one needs to start, and we have seen so far that more or less in every country, they assign a water area where they want to start this development. That makes life easier, much faster, and also we know exactly who to talk to and the stakeholder to work with. We have our own, what we call wind farm laboratory, and that means that we can actually take each potential site, take the water areas, the wind speed, and we can calculate whatever is needed in order to make a decision start the activities and also attract investors. I will now take you to 3 projects, and the first one is our demo project. Norway has done exactly what I'm now saying. They have set aside a water area. They have invited a number of companies who holds technical, construction, and also projects potential. In our case, we have our own patents. We have invited and we now have signed and worked with Burnley in order to develop this. And the whole project plan is that we will have our first demo site up and running in second half of 2023. This project, with about the size it is, with the cost it will have, because it's the first time demos, it will be a little more expensive. But this whole project, we more or less could be copied and pasted down to Indonesia as a discussion, if it's possible not to do it. During the meantime, we are doing second project, and this is a similar project done in England, outside Cornwall, where we will have 2 platforms, and it will be a scale production and delivery into the grid. So this will be the first project for us where we have going from A to Z, from the scoping into the full production and delivering electricity into the grid. This is also a preparation for all the new auctions that will come in England as well. And the third one is what we are doing with the company at Konya in Spain, where we are also funded by the EU. And the whole idea is that our floating offshore wind solutions shall supply them with hydrogen. And this could also be an interesting part for Indonesia. It's not a huge scale. It requires offshore waters, which means it could be flexibly assembled, flexibly towed, and flexibly located wherever the wind speed and the bottom conditions are the right ones. Conclusions. What I've learned throughout my working with Hexicon is that you need a strategic partnership. In South Korea, we find the right partner. They came from the oil and gas industry, and they have
secara mendalam
contacts. We were awarded the feasibility study right away. I led that study, and after a few months, we were also invited to a strategic discussion with another region. And I will show you the next slide. Yes?
5 minutes left, yeah, last.
Yeah, no problem whatsoever. And what we do, yes, we operate with local partners. We believe that's the only way to do it in order to gain the traction in the local country. And the partner can be EPC, it could be a straightforward investor, but we need someone with local knowledge. And as I said before, we can more or less copy our Norwegian and UK project, in all these 3 projects. And what we've seen so far, once we get the decision from the government and the approval, we will deliver electricity 2 years after we have all these permits. Things that we really need to talk about is you have to decide if you want offshore wind. If you want offshore wind, we need to discuss what water areas can be set aside. We have all the insights and measurements to support you there. Collaboration. Yesterday it was decided and it was announced that we now have in Indonesia a collaboration for the Sweden-Indonesia Sustainability Partnership together with a lot of companies through Business Sweden. And we look forward to be part working with you as well in that one. And we also know that we can deliver the electricity. I would also like to add, I worked with stakeholder management throughout the last 2 years, and it's the only way to do it. Start working directly now. Don't wait until you have all the grids or roads, things like that. You can do all this in parallel. Sweden lost about 5 years by wanting to do 1, 2, 3 in a row instead of working simultaneously. It's sad, but it's reality. You can totally learn from Europe and offset some of the learnings we should have done earlier but didn't do. And this is actually what started all of us. It was a wind power industrial exhibition in South Korea. I was there. And from that, the rest is history for Hexagon. We have grown enormously from that moment. A little bit of a vision. You can take an area. I took Noratai as one of them. And also, I would like to stop here. Thank you very much. I'm more than happy to answer any questions.
Yeah. Thank you very much, Mr. Lars, for the good presentations. It was very interesting to discuss about the offshore wind farms, and it's good to share us about your experience. Yeah, how about that project, and also keen to find the local partners to develop the offshore wind farm. It's very interesting. Okay, thank you, Mr. Lars, again, and we'll have the latest panelists at this moment. Is from Mr. Arka Wirya Wijaya, Market Development Director from GE. I think Pak Arka is ready, yeah?
Hi, Panda. Yes.
Okay,
I am.
Yeah, the time is yours. 15 minutes.
Okay.
Yeah.
Mbak Alma, I think Mbak Alma will be sharing the screen for my presentation. Mbak Alma, can you help? Okay, thank you, Pak Agung, Pak If, Pak Andang, also for the panelists, Lars and Eric have learned during your interesting session as well. Assalamualaikum warahmatullahi wabarakatuh. Hello, good afternoon, morning, evening, wherever you are calling in. My name is Arka Wiredijaya. I'm the Market Development Director for GE in Indonesia, looking after 4 businesses here in the country, power, renewable, aviation, and healthcare as well. Today I will be sharing about the offshore wind industry and technology for the specific part. And this session, please feel free to ask any questions after this or even after the seminar. Next slide. So GE is a 125 years company that operates in 180 countries that focuses in energy transition, precision health, and also future of flights now. Maybe quite linking with the EBTKE CONEX in the future of flights, we're also looking for sustainable aviation fuels at the moment for our engines. We used to have a wider range of business ranging from oil and gas as well and transportations. Maybe next slide, you can also see. Next slide. Yeah, as you can see here, these are basically the main businesses that we have. In Indonesia, we also have the similar presence. So for power renewable, we contribute 30% of the power being generated and distributed here in Indonesia. For aviation, GE has the biggest jet engine fleets flying in the Indonesian airspace, and also for healthcare, the high technology across the archipelago. We used to have other businesses, oil and gas, and also transportations, and also with many other businesses before. Next. So today we'll focus a little bit more in the GE renewable piece of it and see how we fit into the energy transition and agenda for Indonesia. Next slide. So we have a complete range of technology that provide a complete set of energy transition offering, starting from the onshore wind, offshore wind, solar PV, hydro, and also pump storage even, and battery storage. We have around 400 gigawatt installed for clean energy footprint globally. And for today, specific for the session, we'll discuss a little bit more on the offshore wind part of it. Next. Maybe before going into a little bit details, perhaps it will be great to have a little bit step back a little and see the market as a whole. This is basically a view from GE, but I believe the others are seeing the same as well. Renewable is going to be the future. Wind, solar, LCOE, we believe will bring more and more aggressive penetration, even offshore wind in the coming years with the advancement in technologies, economic of scales, and also the knowledge that is going to be built up. As for gas technology, we believe it is also still going to be important, moreover during the transitions in which it can be converted into hydrogen as well, providing stable and much lower CO2 emission compared to coal. And one of the aspects that need to be considered is on the grid side as well. Grid will be very crucial to make it very robust and reliable to accommodate more and more renewable penetrations in the market. And we can see on the right hand side, basically we believe that renewable is the way to go. Next slide. Again, from the chart, we can see how renewable has been successful penetrating the market. LCOE has been dropping greatly, some at grid parity as well, giving renewable a very huge advantage moving forward. We can also see in the middle and on the right-hand side, basically the breakdown and the investment in the sector. Wind, both on and offshore, will be among the top in terms of investments. And T&D, again, as I mentioned earlier, in this part of the world, specifically for emerging market, where grid is not very strong and also need to be upgraded for new installation as well. For offshore, the number will continue to grow, we believe, maybe as the previous presentation from Lars and Eric as well, by going a little bit deeper and further from the shore. We believe that the potential will be huge in the coming years, and also with the right economics on hand. Next. Next again, maybe let's dive into deeper in the offshore part. Next slide. So the market for offshore has been in the US and Europe, slowly coming into Asia, Taiwan, Japan, Korea, and hopefully Indonesia soon. For GE, it reflects the same with the market. We currently have we're more or less 1 gigawatt of installed base, and then a backlog of 7 gigawatt to be executed in the coming futures. The market has been for water depth below 60 meters mainly or mostly at the time being, and the market as well as all of the stakeholders are exploring for deeper water to be explored. And based on the study, most of the offshore wind opportunities are located basically in the area deeper than 60 meters, right? It's quite similar of what the other panelists has presented as well. So with further collaboration with stakeholders, we will be seeing more and more of these projects further and deeper, bigger and more efficient as well. Next slide. This evolution is quite important to understand that the turbine has grown over time because of the technology advancement. It is now bigger, it is now taller compared to years ago. So maybe a couple of years back, our offshore wind turbine has a rotor diameter of 150 meters and power rating at 6 megawatt. As for today, we are at 200-ish meter diameter and 12 megawatt power rating, and most likely launching soon bigger and bigger rating to come along with the other players as well in the market. So this sort of enable us to provide higher annual energy productions and lower LCOE as a result. Because with bigger rotor size and bigger swept area, we can have higher annual energy productions and hence creating more competitive advantage for the industry. Next slide. Yeah, this is very site-specific cases, as you can see the number, but most of the time, the bigger the better when it comes to turbine. Of course, a lot of parameters to key in. This is what you're seeing is the Haliade X 12 megawatt. Currently, is the biggest commercially available turbine with a higher rating, which with bigger rating compared to previously, right? You can basically reduce the number of turbines needed to achieve a certain capacity of power plant, which definitely helps in optimizing the numbers of foundations needed, the shipping, installations, and etc. Next slide. Yeah, this is basically just to give you the perspective out of it. You can see, I believe some of you have flew with A380. You know how massive their plane is, and you can see the wingspan is even shorter than one blade of Haliade X. Next. Again, as well, in terms of the height of the tower, it gets bigger and bigger. It has increased to 248 meters now. You can see how it compared to different landmarks across the globe. If I am not mistaken, Monas is somewhere around 100 meter. I don't know, maybe Pandang or Pagung knows better.
140 around.
Yeah?
Yeah, around 145, I think.
45, exactly. So you can see how huge the turbine is. Maybe the next slide you can see how it looks like next. So this is just to give you the picture, right? I mean, the nacelle is really massive. You can see how it compares with my colleagues back in the factory. It's like coming out from a Star Wars movie. I like to see the picture. It weighs around 850 ton. So you can sort of get a sense on how the complication will be in terms of delivery, installations, and everything. And forget also to mention, in terms of the capacity factor for offshore, it is slightly higher because it has a better kind of wind condition as well on the water with less obstacles surrounding it, typically around 60-ish%. Next. Yeah, so this is basically a high-level wind map for Indonesia, right? This is a publicly available data. We can see here the darker the color, the higher the wind speed is. So brown and dark brown is getting more and more wind speed. We can see several wind pockets across the country on and offshore. If someone told you 10 years ago that the wind was not a great option in Indonesia, maybe it was a little bit correct back then, but with the technology advancement, again, economic of scales and the growth in the industry, we can see that wind is now getting much better, and turbine now, by being bigger and higher, can actually capture more wind and turn it into more annual energy production as well. Next slide. Okay, so when it comes to offshore, the turbine portion is maybe around 25% out of the total project costs, and you have, of course, other components in place. For example, foundation structure is one of the most important ones as well. This is just to give you a picture on the options for fixed foundations that are available. Well, again, depending on the site's requirements and everything. But
kita juga akan mempertimbangkan kondisi tanahnya juga atau kedalaman lautan yang akan kita eksplorasi.
Right, specifically for floating foundation, this will surely open more opportunities to come because most of the offshore wind potential are basically located in the water depth more than 60 meters and far offshore. Next slide. And to give you a glimpse of how it looks basically inside the nacelle, this is basically it. We will have for the electronics and mechanical components, and basically everything before sending the electrons to the offshore substations and then eventually to the onshore substation for being transmitted further. Next slide. A high-level installation flow give you the sense of how the high-level process looks like. Normally, it is prepared on shore on the port before being delivered to the site for installation. Again, with a special vessel for shipment and installation. Different challenges with onshore and offshore between them, specifically on the logistic part of it. For onshore, sometimes you need to pass through a very dense population area. In Indonesia, for example, there are a couple of projects that has to cross 300 or 400 overhead cable crossing from port to the site. So you can imagine the complexity might be a little bit different. For offshore, maybe you cannot see those kind of challenges, but definitely the weather conditions and the other stuff are being very tricky as well sometimes. Next slide. Yeah, after commissioning, the other most important portion is definitely on the O&M side of it, right? So depending on the distance of the site and other conditions, we definitely need to work together on this with our partner to make sure that we can spend more time on shore instead on the water, right? So several different strategies to put forward by having all activity and preparation onshore or some of it offshore, depending on the distance between it. We can have everything onshore, or we can have a special vessels in between to make sure that we can sort of cater the distance and also the requirement of the site to be available. Next slide.
2 minutes left, Pak.
Yeah, no worries. Almost finished, Pak. So this is actually my last slide. So for us in GE, as I mentioned on the O&M, we try our best to leverage the digital and robotics equipments to make sure that we can spend and analyze onshore and prepare the action based on the data that we are receiving, right? So hence, we will reduce time on the water and reduce costs, again, reduce risks, and eventually increase revenue for the plant owner. So that is actually it from my side, and hope that the presentation is helpful, and also hope that the wind industry in Indonesia, both on and offshore, will see more and more tractions in the coming future. But again, thank you so much, Pandang, for having me, and looking forward for the discussion.
Thank you very much, Parka, for the good presentations. It's very interesting to see the biggest offshore wind turbine. It's almost higher than Monas, actually. Yeah. And it's really cool regarding the capacity factor, can reach more than 60%. Okay, I think we have around 25 to 30 minutes to Q&A. We have here one question from Pak Adit Bayu Bisono. Okay, thank you very much again for 3 panelists. We'll start with the question and answer.
Pak Endang, before goes to question and answer, allow us 3 minutes to share certain slide of Abu. Yeah.
Okay. Yeah, this is special request from the chairman of association regarding the last 3 pages of the slides about the Indonesian wind farm updates. Yeah, please, Mbak Abu Alma, to share the screen.
Slide 15, 16 tadi.
Yeah, this is very important, audience. Yeah, sorry to skip for the Q&A. I would like to ask about maybe maximum 5 minutes to share about the IUPTL. This is the last 3 slides that should be shared.
Please, Mbak
Hello,
Alma.
Mbak Alma.
Yes.
Okay. Slide number 15. Yeah.
Okay. Who is want to?
Okay. Yeah. This one. Yeah. So, allow me to. Yes. Thank you, Pak Endang. Yes. Next. Yeah. This point. This slide and another slide. As we understand, the government just released the green RUPTL on the 40.6 gigawatt additional for the next 10 years. And this time, more than 50% is come from renewable. And wind got allocation 597 megawatt. Yeah, looks like small, but please we go to detail. Yeah. So the 595 megawatts, 597 megawatt, it will be COD by 2026. Yeah, by 2026. See there, they compare with solar, they got more than 6.6 more than 4.6 gigawatts. So it is the condition, the facts. But we can change it later as become opportunity for winds, yeah. Because solar needs a very massive land, yeah. Next please. So how we divide the 597 megawatts for the next for the 5 years for next 5 years projects? Based on the developer, PLN will build 310 megawatts. And then the IPP almost 300 megawatt. I mean, PLN built more than IPP for the wind power. Yeah. But for the 297 megawatts, all of them not signed PPA yet. Yeah, no PPA yet. Yeah. So where is the where to build it? The 110 megawatt built in Sumatra, and then 270 megawatt in Java. In Kalimantan 70 megawatt, and then in Sulawesi is 170 megawatt, and in Nusa Tenggara mostly in Sumba and in Pulau Timur is 27 megawatts. Now, this is the opportunity. Look like a very small portion for wind, but please remember that Indonesia now in phase out coal period. So it is more than 30 gigawatt coal to be phased out, and every renewable energy get opportunity to replace it, as long as the price of the price plus the storage for wind, it is meet with PLN's economics, and then this is the opportunities. Please back to 10. Please back to slide number 10, Mbak Alma. Slide number 10. Slide number 10. Again. 10. Yes. 1. Please back to number 10. Slide number 10. Yeah, that one. So again, we have more than 3 gigawatt measured wind potential. It means we are ready to supply more than 3 gigawatt because it's already measured. It is already passed wind resource assessment, and it's already known by PLNs. Yeah. So we hope the wind industry, wind communities, and wind developer not pessimistic with the number almost 6.6 gigawatts, but please be optimistic, because we are challenges by government now, by PLN now. If we can replace the fossil fuel, and then it is the bigger opportunities. I think that's all, Pak Pandang. Thank you, and then we go to question and answer question. Thank you.
Okay, thank you, Fai, for the additional explanation about the status and highlights of the wind farm project in Indonesia. Hopefully, as Pak If Naldi, as Vice Chairman of the association, we have an optimistic feeling to support this green power plants, which is, we believe that Indonesia has a huge market with the huge population. And of course, we need huge electricity, And as you know, that all countries around the world are very concerned regarding how to reduce the emissions, and wind farm is one of the best solutions, I think, with the higher capacity factors. Not only for onshore but also for offshore, compared with others, especially in the intermittent power plants. Okay, we come back to the Q&A session. We have here one question from Pak Adit Bayu Bisono. The question is: logistics one of the most challenging issue for wind farm construction in Indonesia. Yes, it's very true. I also see the wind turbine trend is getting even bigger. What is your strategy that this massive turbine onshore or offshore could be installed in Indonesia? Maybe this can be addressed to Pak Arka and also to Mr. Lars. Yeah, Mr. Lars, maybe you can convey your answer. Thank you. Maybe Pak Arka first.
Oh, sure. Okay.
Yeah.
Thanks, Pak Adit. I think Pak Adit is one of the expert as well when it comes to wind in Indonesia. Well, of course, there need to be a balance between having a bigger turbines and having it feasible to be installed, right? So it has to be a right balance among that. Again, the quick answer, perhaps it has to be going through a very thorough logistic study with several options. So you have to understand what will be the options on site, what kind of turbines can be installed and can be delivered actually, and which bringing the best kind of return. So that will be the fast answer. But again, maybe just to share a little bit bigger than that, what GE is typically doing. So we tend to prepare the market and the stakeholders a little bit before the market is happening. So making sure that everyone is having the right equipments, everyone is having the right skills, everyone is having the right licenses to do that, be it onshore and offshore. So that is also very important. When it comes to turbine itself, for onshore, for example, we try to find a way as well to optimize it to help developers, investors to deliver it on site. By having a split blade for our cypress. Not sure if you have heard it. So we can split the blade on the tip of it, 12 meters from the tip, we split it. And we also combine it with a blade lifter kind of scheme during delivery, right? So this can actually quite helping the shipment. Technically, it is helping and also reducing the compensation needed for the project development, right? So that's what I believe. For offshore, I believe it is the same. We just need to prepare the port readiness to be meeting the requirement. Having the vessels and also in terms of the skill sets, I believe fortunately we are great in oil and gas business in Indonesia. I believe there are a lot of skill sets that are quite transferable when it comes to logistics and offshore operations as well. So I think that's my answer, Pandang. I hope that answer Pak Adit's question. Maybe Lars have something to add as well.
Yeah,
yes,
thank you.
I agree
Lars,
with you. Yes, so I agree with you very much what you said. We're actually doing studies at the moment to see if we can not go on the highest level of the turbines, but actually have lower turbines, get actually not as expensive platforms as well, and reduce the cost of steel, etc., etc. And also what we've seen is that, as I explained, we got interest from Shell directly in Korea, and that is because they know and they are used to take risks. And there was a discussion on should we have set up a little bit of a showcase or what we call it, first test of the equipment. They say absolutely no. We know what to do. So please go directly to the development phase and see what the technology should look like, how the stakeholder management should look like, and millions of other questions. So I agree with you. I think we can make it fit for Indonesia as well. Normally we look upon wind speed around 8 meters per second, but we believe it's possible to do it less as well. I believe, if I remember right, Korea is about 7 meters.
Yeah.
So, but
yeah,
my absolute biggest recommendation is start in parallel. Don't wait for all the answers to be there. Then you will take 10 years with you.
Thank you, Lars.
I agree with Lars.
Yeah. Thank you, Lars and Parta.
Yeah.
Okay, hopefully the explanation can answer the question from Bayu. Yeah. Okay, and then we have another question from Bu Cynthia from Pastesa. The question: if we have potential location size, let's say 20 to 50 megawatts around Java Islands, would anyone be interested to join? Also, logistic challenge due to narrow hilly road. Yeah, I believe that all the firms will be interested, right? Interested with the yes, as long as the wind resources meet the minimum requirements, of course. Yeah. Okay, but maybe this panelist can answer and explain the short brief about regarding this question, please. Anyone maybe refer to the Europe expression, maybe Mr. Eric can share your answer upon that question. Unmute.
Yes, definitely interesting sites like 20 to 50 megawatts onshore. I understand of this question. It's absolutely interesting, and it is connected a bit to the previous question with regard to the logistic challenges, as I read in the question. And what you see there is that are huge steps made already with equipment that can go up to roads up to the hills and even make these sharp turns in uphill right now by putting the blades of the turbine a bit upwards so that you can make sharper turns, for example. Equipment like that is developed already, and you see that, for example, in the mountains in Vietnam right now, and it can very well be utilized in Indonesia as well, I think. And 20 to 50 megawatt may not sound too big, but I think for onshore locations that can be very appropriate size actually, because you also have grid connection difficulties often. Can the grid cope with the intermittent power supply? And then 20 to 50 megawatt is a bit better to handle than tenfold in size, for example. So really interesting for sure.
Okay.
You have my contact details in the slideshow in the end. So.
Okay. Thank you, Eric, for the good explanation. Yeah. I think this is sizable, yeah, for 20 to 50 megawatts, and the logistic always be challenging. But refer to our previous 2 wind farm project that has already succeeded and operate right now. I believe that the logistic challenge is not a big issue because due to the export technology and also the logistics wise. Yeah, for information, maybe we know that in Sidrap, the developer have already built the 3 bridges, yeah, and also to enlarge the road and many related infrastructure that have to be built to deliver the all equipments, including the long bridge, of course. Okay, and then this is one question from UPC Renewables, which is a member of the associations. Address it to Pak Agung. Hopefully Pak Agung is still here. I saw Pak Agung is still in the meeting. The question is about the tariff gap. Yeah, about the tariff gap. What Pak Agung mean at how to handle tariff gap of tariff? Yeah, is using the carbon funds or something like that from certain agency. Pak Agung, or maybe Pak If, you can share your idea.
Yes, thank you. Terima kasih, Mrs. RC from EPC.
Yeah,
so
EPC, yeah.
The question about the price, yeah. Once if the new regulation, the President regulation on the renewable energy issued, yeah, with the base on economic, yeah. So we don't need any gap there. We don't need any incentive or subsidies from government to get the commercial power purchase agreement. But if later on the regulation is still not coming out there, we still use the old one based on the DPP. Yes, in some location, in some area, the DPP not match with the economic economic calculation by developer. And then I believe the government has some instruments, some tool to make it working. Yeah. One of them is like a question of Mrs. Arsi. Yes, government to fill the gaps. But of course, it is my opinion. Yeah. Let's wait. Will we have the new regulation or not? This is my answer. Thank you.
Okay, thank you, Pak Ifnadi, for the explanations. Okay, we still have one last question before we move to another session. This is from Pak David. The question is the study conducted by the state of the selling price of this investment versus the product presented here? Isn't it still preferable or not? And it's all asking about the ROI study. Maybe before, I think this is a good question, and here we have Pak Eric as also the consultant, and Mr. Lars from the developer, and also Pak Arka. We can get a short statement, but for info that we have a BPP or tariff determined by the minister decree. For example, for national right now, I think it's around 7 cents US dollar per if, yeah, per kilowatt hour for the tariff. So this is as a reference. I inform this tariff to also the panelists to can make like estimation, maybe short estimation about this existing tariff Yeah, it's of course different area is different tariff. Let's say, for example, for the Eastern Indonesia with the will be higher tariff, and then for Java Island like West Java, East Java is lower tariff from the national average tariff, something like that. Okay, maybe we start with Mr. Lars, maybe. Please.
Yes, I can add an example. In South Korea, they have now had a startup tariff that cover the further you're out from land, the better you get paid. They also now introduced a second measurement, and that is how deep, depending on the depth of the water, you also get better tariffs. So they are really focusing on make this happen and make it happen now. What will happen then in the future when the first big farms is established, that's the second question. I believe that is absolutely the right way to do it, to make the development go faster than slower.
Okay. Okay, thank you, Lars. Maybe Parka?
Yeah, I think this is interesting to be discussed a little bit further, but of course, like you have mentioned, Pandang already, there's a BPP there. In my opinion, with the right wind conditions, the right turbine selections, right layout of the power plant itself, and the right scale, I believe it is definitely going to be profitable. As you know, there's a lot of development happening as we speak now, right? Both onshore and offshore. So yes, the answer is yes. I think that's from me, Pandang.
Thank you, Parka. Maybe from Mr. Eric.
Well, I think actually the tariffs are quite challenging in Indonesia, and that is because the wind speeds are often a lot lower compared to situations the wind turbines apply to normally. So you have to look very carefully into the business case. But prices of wind turbines and levelized cost of energy is going down. So it's especially very important to keep it steady and keep it predictable, because then as a developer, you can look into ways to lower the costs and meet the tariffs that are available. But it's not easy.
Yeah, sure. Okay, thank you very much for the all answers. And finally, ladies and gentlemen, we have finished this session. We'd like to say thank you again for the all panelists and also the all audience that already joined these sessions. And let's give a big applause for all of us. And then we'll have next session will be guided by Pak Ifnaldi as a moderators. That's from me. Thank you very much for joining this first session. Apologize for the inconvenience or some things incorrect in the deliver anything I have. Okay, thank you again for Mr. Lars, Pak Eric, and also Pak Arka for delivering your presentations. Thank you very much. Bye. Please, Pak If, continue.
Thank you for inviting us. Bye-bye.
Bye-bye.
Yeah, bye. Okay, thank you, Pak Endang. Gentlemen, ladies and gentlemen, we come to second session. The first speaker will be from the Baldwin, Mr. Victor. I only give 2-minute introduction. Once, until now, there is no regulation on offshore energy. Yeah, but for onshore energy is already complete. But back to the story, how EPC, how FENA get the first project, it is when regulation not exist yet. So this is the provocative statement. So if you want to try the success of the previous one, so let's the wind offshore developer do the same thing with how to push the wind offshore project Indonesia. So we would like to invite Mr. Victor Setiawan from Godwin, Australia, to convey his presentation. So, Pak Victor, the time is yours.
Thank you, Pak If. Good afternoon, everybody. Thank you for having me for this presentation. I will share my screen now. All right. Hope everybody see this already. Okay. All right. Okay. Thank you for having me. All right. My name is Victor Setiawan from Goldfield, Australia. Goldfield, Australia. Here I'm based in Jakarta, and I'm presenting today about a microgrid, which is wind, solar, and battery. And first, I would like to talk a bit about our company. Goldwind is a global leader in wind energy, and of course, we are also participating in other equipment for energy, for clean energy as well, renewable energy for microgrid like a battery, and also we have some water treatment technology and things like that. But we are in 6 continents and 29 countries. Our assets is about $17 billion US, and our operation revenue $8.76 billion US. And we are listed in 2 IPOs in Shenzhen and Hong Kong, and we have about 8,900 employees around the world. And our installed capacity is over 73 gigawatt plus. Offshore is 1.6 gigawatt plus, and our onshore wind turbines that have been installed is about 40,000 units already around the world. And for the offshore is about 400 turbines already installed around the world. Our ongoing, okay, sorry about that. Okay, 47 gigawatt plus for ongoing O&M services around the world, and we have about 3,000 of technicians globally. Our track record by now is about 75 gigawatt around the world. As you can see in the country list here on the left side, that we have all turbines, all kinds of turbines that in different conditions are or temperatures around the world. And we have also in Australia, which we have about 1.5 gigawatt already installed in Australia. And both in Australia's objectives in Indonesia, we are supporting Indonesia to achieve 23% of renewable energy target by 2025. We have staff already in Indonesia, and we provide renewable solution for diesel conversion plant that PLN has recently. And we would like to help also PLN growing the wind power needs to support the Indonesian economy, and commitment PLN's about the decarbonization by 2060. A little bit about the PLN's program. This is taken from a PLN RUPTL dissemination that you probably already have. About 5,200 plus existing small-scale diesel, which is probably already old, in 1,310 locations, and it's divided by 3 phases. The first phase is 225 megawatt plus diesel generators with some 15 plus years life operation that need to be converted into the solar and battery. And the second phase is about 2 gigawatt plus diesel will be converted into gas-fired power plants and some renewables. The third phase is interconnecting those off-grids into the main grids. This is the strategy that's taken also from the PLN's RUPTL. As you can see that number 5 and number 6, they are really focusing on converting the diesel, mostly all diesel generators, into renewable. So what are the risks that we probably found in the microgrid developments? From that we found is PLN will see that the fuel cost risks. That's why they want to switch the diesel generators into the renewables to get the lower cost of energy generation in the regions. And some of the diesel generators also is aging and unreliable when it comes into the use of the system. So after that, they have also some challenges on the fuel supply. it's really hard to deliver some of the fuels into the isolated islands. Of course, with some poor access, that probably is really hard to reach there, and it's gonna create some bigger cost for them. So that's why they want to switch to renewables. And the fourth thing is a lot of small systems. Once they have renewable transition into renewable. So these are the challenges that I would say it will create limited resources in regional areas, and also the issue about the control and sensitivity, mostly of the created by some old diesel generators that doesn't have a power plant controller, that will create some issues when it comes to integration. And of course, consider the carbon footprint that will be big. As you can see, the second phase is 2 gigawatt plus. So that's a great amount of diesel generators that need to be converted into the renewables. As of the infrastructure, of course, you can see in some of the islands there, smaller islands, the infrastructure to reach this is not available. Of course, some of the high-speed internet is also not available, and that's going to be challenges for them to face. But if we combine all this into a good strategy and a good planning, it will create a great amount of renewable energy fraction. For 4 years to come. The wind configuration, it adds a lot of values into the solar and BESS configuration. And these are some of the elements that we found is needed for wind, solar, and battery to work together. So the first one is the wind power plant, solar power plant, and then the battery energy storage system. Of course, in the BESS, we'll have energy management systems, power plant controller that will integrate into the some of the diesel generator that has a DG controller, utilizing the existing diesel, which that still, I would say, deserve to be operated. But then after that, if it's not possible to use, then it will be replaced by the gas power plant. Of course, the balance of plant will be there, and we still need it, and the SCADA system. So the system will work together and reach the goal of LCOE. So most of the projects now that we've seen, solar have a great amount of quota from PLN, but we hope that to add wind into the installation mix, that will help to reach a redundancy of needs of renewable energy. So the intermittency still have a lot of, I would say, issue that has been talked about in PLN and whenever there's seminars, and it's really, I would say, makes it unsuitable for islands with high load demand. It's only solar and BESS. But
5 minutes, yes.
Yeah, okay.
Okay, yeah.
But if storage with a combination with solar, it will create microgrid with higher representation. There are some challenges and solutions that you can read as probably I don't have enough time here. But the main thing is in order to design a good microgrid is to have a large amount of energy that is available, and some limitation on the battery storage, because as you know that battery space is still expensive nowadays, but it's become more affordable. To design the microgrid, we started with all the forecasting data, including the load data, wind data, solar data. Those that are needed to be analyzed, and to be effective and comprehensive, needs to have more forecasting and algorithm that will create a proper profiles for the needs of the demands in the system of the island. And the energy management system will help to control, will help to coordinate, and it will help to reach some of the goals and distribute the energy evenly into the system. These are some project case that we have done. This is in our campus, in our headquarter office. We generated about 4.8 gigawatt electricity from the microgrid. And then the second case is in Australia, where we have a mining city that needs to have a off-grid microgrid. So these are 17.85 megawatt of wind with 4 megawatt of solar, and the battery is 4 megawatt hour. So these are already some operated projects already. And for our products, we have a wide range of products that available, from the small turbine up until the biggest turbine that we have for onshore, which is 6 megawatt. And these are the turbines that we have a special technology called the permanent magnetic direct drive that will have that was suitable for the small grid, and we friendly because we have a Type 4 generator that is power conversion, that is we do it full power conversion, which means from AC kinetic energy to DC, and then we convert it back DC to AC, so it'll be very friendly for the grid, especially for the grid that is small in the island. These are some of the example that we did. This is for 2.2 megawatt only for the projects, and as you can see, we also work with solar and BESS. The battery is around 1 megawatt hour. So we simulated, we help the customer to reach their goals, and we size it based on what they need in the loads. So it works together with the wind, solar, and battery. So this is the estimation fraction. It's 91.6% renewable energy fraction, which is quite high, and it still creates about 1,084 per kilowatt. So this is the highlights. We have since we have this small turbine that is completely perfect for islands, because the transport will be the issue, and the transport for small turbines is become more sensible and it's transportable. And we also designed this with this variable speed, variable pitch control wind turbines, permanent magnetic drive, full power conversion, and robust inaccurate power control. We also have a battery storage solution from our sister company, Golden EBTKE, that makes it integrable and seamless integration will create high reference. So with this, I think I'm gonna, if you have any questions, I'm gonna have that open. So go ahead, Pak If.
Thank you, Pak Victor. Thank you for the very informative, very knowledge presentation. You already mentioned Indonesian program like diesel to renewable conversion, which is put wind as a solution, but we also need the conversion for the big scale, because we also in phase out coal program. I think there is some question for you on the Q&A session and later. Thank you.
Okay. Thank you, Pak If. Yep.
Okay. The second question. So we have the ladies here. The only lady speaker on our Indonesian forum, Indonesian Wind Forum, from PT Awina Sinergi Internasional. First, we convey the congratulations to Awina because Awina winning award from the METI, from Indonesian Renewable Energy Society, as the one of the best company in renewable energy. So Mrs. Siti Badriah, the time is yours, please.
Okay. So this is in English, Pak.
English is okay. Indonesian is allowed, yeah.
Okay.
Thank you.
Okay. Thank you for the opportunity and also the congratulations from Pak Aldi. Thank you. I think it's just the start. I mean, even we already passed 10 years, but it's just the beginning, because our target in net zero emission will be next 39 years, because our target to achieve the 100 renewable energy in 2060 at the quickest. I hope we can achieve faster and faster. Okay. Wait a second. My screen is freezed.
Yeah. So,
can you see my screen?
Still on the process.
Yes.
Yeah.
I don't know, maybe the internet connection. Oh my God. It's internet problem.
Ya, please Dian, please atau dikirim ke Alma, dikirim ke saya atau Endang, silakan. Nanti kita bantuan ya.
Probably the next speaker probably while waiting my turn. I think I have problem with the connection here. I'm really sorry.
Okay, Mr. Hans, are you available now?
Yes, Pak Ifnaldi, I'm available.
Okay. Due to technical problems, we move to the third speaker, Mr. Hans Christoph Bromberg from the VPD Energy. First, of course, we thank you because VPD is already become member of the Indonesian Wind Energy Association. So, Mr. Hans, the time is yours, please.
Okay, thank you very much. And thank you very much for giving me the opportunity to talk to you today. Actually, we have already heard several things about offshore wind, and nevertheless, I hope I can contribute a little bit more with my little presentation. Now I just need to get it started. So yeah, let me briefly start with a quick introduction of WPD. WPD is basically a group of company with a headquarter in Bremen in Germany. We are engaged in basically everything along the wind value chain, starting from the development, construction, the financing, but later on also the operations and the asset management of renewable energy projects. So far we have developed and built more than 5 gigawatts of projects. We are focusing on onshore wind, offshore wind, and solar PV technology. And right now we have around 3,600 employees in the group, and we have a global footprint active in more than 28 countries. And when it comes to Indonesia, we started our operations the beginning of this year. We set up our subsidiary PTWPD Indonesia Energy in Jakarta, and we're very happy that we have already found some very experienced team there in order to progress with our developments and bring our technical competence from our international business to Indonesia. We hope that we can contribute with our technical competence, but also funding and financing capabilities to the further growth of renewables in Indonesia. When it comes to offshore, we basically engaged in all the various development processes, starting with identifying the sites, then later on doing the permitting, the contracting for the components, financing, and later on construction management during the execution, and also the operational management via our subsidiaries. Currently, we have around more than 350 team members, engineers from various backgrounds, purely dedicated to offshore wind, and we hope to build on this experience also in future markets. We have been responsible for the construction of 3 offshore projects in Germany, amongst them also the very first offshore project, the commercial offshore wind project Baltic 1 in Germany, built in 2009-2010. And currently we are leading the construction for a 640 megawatt offshore wind project in Taiwan, the Yunlin project, to be commissioned next year, and in parallel 2 offshore wind projects in France with a total capacity of 1 gigawatt, Fécamp and Calvados. Offshore wind has seen obviously tremendous growth over the last years, starting with few markets in North Europe. It expanded then into further markets in Europe, but also overseas, for example, to China. We have seen significant installations over the last 5 years in China. But the Global Wind Energy Council predicts also for the future further significant growth of offshore wind, and not only in the already established markets in Europe or in China, but particularly also in new regions like North America and further countries and markets in Asia. Several countries, or most of the countries, have just recently set quite ambitious renewable energy goals, but ambitious renewable energy goals also require large-scale renewable energy sources, and we believe offshore wind fits perfectly into that. Not at least also because offshore wind has seen significant cost reductions over the last years. A good indicator on that costs are going down are obviously the developments of feed-in tariffs or the bid or strike prices in auctions. While most of the markets have implemented fixed feed-in tariffs at the beginning in order to enable the establishment of the new industry and also the development of supply chains, later on competitive auctions can help to further drive innovations, but also decrease the cost and the bid prices. In France, we have, for example, seen the very first auctions there, bid prices or projects with award at around 200 euro per megawatt hour, which is around $225. But recently, projects in the Netherlands and also Denmark have been built at tariffs of only 50 to 70 US dollar per megawatt. And most recently, we have seen awards for projects in the Netherlands and in Germany to be built in 2023, 2025. With so-called zero subsidies, meaning zero bids, meaning no subsidies are required to build these projects. Obviously, bid prices and tariffs depend a lot on country specifics. For example, the wholesale market price for electricity, provided infrastructure, and further costs or subsidies of other energies. But actually, the decrease in the costs we have seen came quicker than anticipated. And actually, several studies and experts project further decrease of the levelized cost of energy of offshore wind of around 17 to 35% until 2035 and up to 39% until 2050. So basically, the potential of offshore wind to offer a very competitive levelized cost of energy is significant. Yeah, the levelized cost of energy is generally defined as the sum of all costs over the lifetime divided by the sum of the entire electrical energy produced over the lifetime, and helps to compare and evaluate cost of electricity production from different technologies and different locations. But in order to understand why these costs are going down or need to go down and how they go down, obviously we need to have a look into the main contributors. It's on one hand the capital expenditures and its cost of financing. the operational expenditures and obviously also the decommissioning expenditures. On the other hand, the level of energy production and also the lifetime of the project. CapEx and the financing costs account obviously for the biggest portion, often 2/3 of the costs are coming from CapEx and the financing. And cost reductions can come from process or technology changes in the manufacturing, in the installation, or also in
5 minutes,
operational phase. Okay. Yes. So let's have a quick look into what contributes to these cost reductions. First and foremost, obviously, it is the turbine size, the increase in turbine size, bigger capacity, larger rotor, and higher tower lead automatically to better capacity factors. According to some manufacturers, 14 megawatt turbine will account for more than 10% increase in the annual energy production compared to a 12 megawatt turbine. Less numbers of turbines lead also to less numbers of foundations, inter-array cables, and installations. Less turbines obviously also lead to reduced OPEX. And the average size of an offshore turbine increased from 1.5 megawatt in 2000 to 6 megawatt in 2020. Actually, if we look at Europe, it's even 8 megawatt the average size. So basically, the technology or the increase in the turbines have played a significant role to drive also further developments. Looking at the foundation structures, we have seen so far mainly tripod jackets, tripile and gravity-based foundations, and monopiles. And monopiles account for the by far biggest share. Monopiles are easy to manufacture, easy to design. And while at the beginning, monopiles were only available for water depths to 20 to 30 meters, over through technology and design improvements, monopiles now can also be installed in water depths up to 40 meters. So that has obviously led to significant cost reductions also on the substructure part. To install a blade in 100 meters height, you need a stable platform. And while at the beginning of offshore wind, floating barges and converted cargo ships were used, which led often to standstill and weather downtime. Now specialized installation vessels, which carry up to 12 sets of turbine components, and with increased weather limits up to 12 to 14 meters per second, have seen significant reductions and very efficient installation methodologies. Obviously, also the standardization of offshore substations, increase in voltage levels for the inter-array cables from 33 to 66 kV has led to a reduce in the losses. And also the utilization of high voltage DC current technology compared to high voltage AC technology has improved the efficiency of entire offshore generation systems. And last but not least, obviously for onshore turbines, a technician can always come to the turbine when there is an outage. For offshore, this is more complicated. Therefore, the introduction of condition-based and predictive maintenance has led to a significant improvement of the availability of turbines. In addition, also tailor-made service concepts with heat-compensated access systems have increased the availability and at the same time reduced the OPEX. Summarizing, I think we can say that technology developments have already led to significant cost reductions, and it will continue to decrease. Capacity factors nowadays of offshore wind farms are even close to efficient gas turbine power plants. And while we currently only have seen pilot projects for floating offshore wind is about to reach the commercial viability and will significantly expand opportunities for offshore wind. And last but not least, offshore wind is also working as an accelerator for the development of large-scale green hydrogen production, which obviously can contribute in various ways. Summarizing, we see big opportunities for emerging markets, not only for the developed market, but also for emerging markets like Indonesia to tap into this huge potential of offshore wind. And we as WPD would obviously be very happy to also support and contribute to the country's development in that direction. Terima kasih. Thank you very much.
Thank you, Mr. Hans. Thank you for the very relevant presentation. You mentioned LCOA. In Indonesia, LCOA is very important and very sensitive because we still use the least cost principle. We have only a single off-taker PLN because we have all of the kind of the energy. So LCOA is become important. Okay, I think you got some question on the next on the question and session session. We come to the last speaker, Awina. So as Pak Arka said, the bigger is better, and then Pak Victor compare the medium ones, like for the conversion program, like 2 megawatt up 3 megawatt. But in Indonesia, the micro turbine also important. So now we will enjoy the presentation from the Mrs. Siti Badriah. Please, time is yours.
Thank you very much, and thank you, Mr. Hans, for replacing my turn. Okay, yeah. The previous speakers focused on large-scale wind turbine. So our company focused on micro turbine, 501 kilo so far. So we have been in Indonesia since 2010, and yet our development so far, I will share what we have done in Indonesia. Aside, we are doing the marketing opportunity and also the local content production in Indonesia. Okay, this is the reference that has been mentioned by Pak Agung before, the only reference for small low-speed wind. The range actually about 3 kilometers wide range, but with this wind map, we can pin in every map here, and this is very detailed because even I can find the wind, like here in my office in South Jakarta, I pin the map on SMESCO, and I can track, even this is 3 kilometers range, but I think this is the most suitable wind prediction that we can figure out. Actually, not so much different between mainland or in the coastal area. Below the 50 meters or 75 meters, here in Jakarta, it's about 3 meter per second to 3.5 meter per second. And when I pin to the Jakarta coastal area in the Pulau Seribu, the wind speed there under 50 meters, about 4.3 meter per second. So our target, usually our micro turbine, 501 kilowatt wind turbine, usually we just install about 10 meters from the ground or in the rooftop of the building. So actually we rarely put with the pole height of more than 20 meters. Besides, this is in the top of a building, of course, it will become higher. So our target is to harvest wind energy source in the lower ground from 10 meters to 15 meters in the top rise building. So usually this prediction is about 2 meter per second to 4.5 meter per second. And yeah, this is our 1 kilo spec. It's very light. Our wind turbine, we have 100% green material from wooden blade. So the blade we produce from now is local wood from Indonesia. I will tell later. And this very light motor, it can rotate even the speed from 1 meter per second, but the cut-in speed or charging speed usually around 2 meter per second to produce the energy. When we see the graph here, actually under 3 meter per second, it's very low, the energy production, even the generator already spinning. However, if we can harvest the wind energy in the range of 3.5 to 4 meter per second, we can harvest more than 1 kilowatt hour per day. And if we can, if we put the wind turbine in the good location, we can harvest more than 1.5 or even 5 or even 2 kilowatt hour per day. So I think our micro turbine usually will work for the average in this wind speed. And yeah, that's the basic performance of the generator. And this is from Japan. So the history actually starting 97, where, sorry, in 1997. But then since when we came to Indonesia 10 years ago, we are targeting to produce this product locally in Indonesia. So step by step, we collaborate with many institutions. At first is biomaterial LIPI. We research with mahoni and jati or teak wood to be as the wooden blade here. And then in 2018, under the research grant for the generator, we research with the Department of Physics in LIPI also. And the challenge, probably it can be replaced with local content about 50 to 60%. The mechanical body coil and the magnetic installation we can do here. And also the wind speed output test we can do in BPPT or BRID. But the challenge for the magnetic material and electrical component is very hard, even for small micro turbine to develop in Indonesia. And 2019, we try to make local some part of local content with 10 units we test in Department of Physics. And 2021, we try to develop software for online monitoring system. And here the wooden blade test, we use the CNC machine in biomaterial LIPI, and it takes about 2 months or 3 months to get the perfect wooden blade, because we have to know the many indicators of the material of the wood. For example, like the texture, the water content, and also the type, the typical of the wood. And then we do coating with polyurethane, if I'm not mistaken. Yeah, so it's about at least 2 or 3 months to produce one set of blade with our current small project. Here I can share a little bit about this. Yeah, that's part of the equipment that Biomaterial Research Institute has to support our wooden blade microturbine. And here the generator part actually is very laboratory scale research, like to make the coil and then the mechanical body, etc. We do it before COVID, two years back. And this is the online monitoring we are still developing. So we hope we can come up with the perfect apps. Yeah, it's the history from Japan actually. When we install in the Mongolia desert, when the monitoring weather from solar is covered by dust, so they need the complement energy from wind turbine. So that's the very first beginning of this micro turbine. And since 2007, our company has been set up, and we try to make a pilot project in one location in every country, including Indonesia. And now we are focused for the international market. We do in Indonesia. And yeah, there are some projects of course we combine with the solar PV for the energy, because we usually rare to build one turbine, wind turbine itself. So usually we make a complementary power source with solar PV. So we use this one for water desalination, and this one, the support also, I think Pak Endang and also Pak Chandra and Pak Agung knows this project, and they are involved in this. So this, I think, part of the CSR from their company. We installed this, and so far there is no. It's back in 2015, and no comments yet to me. So I don't know. I hope it's still
works well until now. It's good.
Wow.
Yeah.
Alhamdulillah.
Well,
Okay.
I've been there too.
Okay. Yeah, I think we need this kind of small energy backup in the remote area, or yeah, especially in the very limited access to electricity. And this one in Lembang, in the Pak Chandra, I think one of the member and Energy Angin Association, and this is also in his foundation in Bandung, and this part also in LIPI before become BRIN. Yeah, usually we try to collaborate with the research partner in Indonesia. Aside, we are growing the market access in Indonesia. And this is the project of Zeus, company run by Pak Chandra, and with the small system hybrid with solar PV in 3 villages. There's no grid electricity yet, so even very limited lighting access, but during the night time, the lighting is very essential for them. So it's part of small power source from hybrid wind turbine. Yeah, and this is some like university research, and this one in Lombok in 7 schools, part of the Renewable Energy Learning Center in Lombok. Yeah. And this is the place of each school. They are learning the green energy source. And this one also in Governor of Bali, they are testing how to harvest from wind turbine connecting to their office grid. And yeah, this is in Ciheras. Maybe if you know, I think everyone will know about Mas Ricky. We support the project also here using our turbine. And yeah, I think that's all. And the last we did in this 2021 in LRT station in Cawang, they try to make a green mission with wind energy profile. So they installed 2 units in front of the LRT Halim Jakarta. And this is in the hospital. We built the hybrid solar PV with battery for the electricity backup in the hospital. And we built 1 unit of street light from wind turbine. And yeah, I think that's all. Oh, the latest, we in October, for part of our testing of our online monitoring, we install 2 unit in NTT, 2 unit in vocational school, and now our team also prepare for the installation in Papua, in the mining site. Yeah, I think that's some of our project that we have now. So I think we can make a real green energy together. Okay. Thank you, Pak.
Thank you, Miss Siti. It is very, it is very informative presentation. I think big applause for you. So, dear participants, big is a must in Indonesia. Small is necessary, but micro also needed. Both onshore, offshore, we need it. So, I think we come to the question and answer sessions. Please, participant, you may write the question on the chat box. I think I will read the first question. This question goes to VPD. Sorry, he not mentioned the names. Question for VPD: do you have vision for offshore wind energy for Archipelago Indonesia as well as Philippines? Yeah, please, Mr. Ram.
Yes, thank you for the question. And I mean, in all the markets we are moving in, we are looking also into offshore wind potential, and currently we are obviously also assessing Indonesia. We have also offices in the Philippines where we also see obviously the shift towards renewables and therefore also the need for offshore wind. We believe that most likely it's nothing which is coming in the next 2 or 3 years, but we strongly believe with the technology developments which we touched previously, and also with technology of floating, that there is potential for offshore wind in Indonesia, and we as a developer know that sometimes also a little bit of patience is required, and a lot of groundwork and discussion with officials. So we are here to also do that. Yes, we definitely believe that countries like Philippines and Indonesia also have the potential for offshore wind.
I think I will make this question more sharper. The question from Mr. Herdis, because when he mentioned archipelago is mean the island, could be small island. So the question is goes to Pak Hans and also to Pak Victor. What is the minimum size that you mean can be developed by the company for offshore wind? Yeah, for offshore wind turbine. But not only offshore, asking for offshore and onshore. Yeah, what is this the minimum size?
Yeah, I mean, that's a bit of a tricky question, and it depends also on the markets and on the development of the supply chain. Obviously, offshore wind is big scale, and we have seen that first projects in Europe started with around 50 to 100 megawatt, then 300 megawatt a project. Nowadays, we are talking in Europe and in the other countries of projects 500 to 1,000 megawatts. So these are really the big projects which can also substitute big other power plants like coal-fired power plants. You need to see that investment in supply chain and investments in vessels is required. Therefore, it is probably difficult to say, okay, we can implement an offshore wind project with 2 or 3 turbines. These are pilot projects which probably will be seen in various countries. But besides that, we need to see that offshore wind is rather for the big utility scale.
Thank you, Mr. Hans. I think there's some question goes to Pak Victor. Please, Pak Victor.
Okay, Pak. Well, in terms of microgrid, I think the size it should be simulate or will follow the loads actually. So the loads data is very important into sizing the microgrid. But for offshore, I think it also rely on the availability of the space offshore, because some of the if you see the bathymetric of Indonesia, some of the depth of the ocean, reaches 80 above 80 meter. That's when the project is not feasible because it's too expensive to have a jacket for that depth. So it's really depending on the I would say the forecasting of the data for the microgrid, and also the for the offshore, it's availability of the offshore space. Because I would say in offshore maybe we don't have much regulation here, yeah, for the framework to work. I mean the PPA format even is not available yet. So there are a lot of work that probably we as association we can work together and create that framework. So I think that's the best time to do that, because in the next 5 years offshore will be projects that will be relied into because the size that can reach 23% of our renewable energy target.
Thank you. Please, if you have another question. I think we still have another 30 minutes. Yeah. I think I will open that. Since there is no more question on the chat box, I will open the question directly. Yeah. Okay.
May I?
Yes, Pak Andam. Please, Pak Andam. Yeah.
Okay, the question goes to Pak David. Yeah, I saw from your presentation it was very interesting when you show us about the hybrid wind farm, smaller size with the PV. I saw in the slides there are SIM-phones, right? SIM-phones,
yes,
like tambak udang, Pak, ya?
That's right, Pak. Yeah.
Yeah. So I believe that the scheme should be direct to the owners and no need to deal with the PLNS offtake, right? And secondly, two questions, Pak. First question: how about the commercial scheme to proceed that supply of the hybrid power to the SIM farm owner to avoid the existing regulation that the only off-takers only VNN. Yeah. The second is it workable for, because we have also the shrimp farm in southern of Sukabumi, and there are many from my friends in the shrimp SCI, shrimp club Indonesia, that's they also asking about the utilization of the hybrid power, because you know that the wheeling and also the electricity is a must, but in the sim farm. Yeah.
Yes, that's
maybe
right.
This is maybe one of the solution, but maybe you can explain about that. Thank you.
Yeah. Well, the framework for the commercial is actually it's not available yet, but based on the regulation. But in terms of the use of its own their own electricity, like we imagine like diesel generators as a backup. I mean, some of the companies have that diesel generators operating it based on the izin operasi. So izin operasi based on the Minister of Energy and Minerals, they can get that permits from. And I think there's no limitation for the wind as well. I mean, as long as we make this as a pilot project, and then we create this framework and we propose to the Minister of Energy Minerals, EBTKE, and I think this is something that will work for a small system, because the availability of the electricity is not there, I think the minister will support, So that's the advantage as well. Then plus the in terms of the area that needs to be developed, like for example that press that just came out. I mean, a lot of system that is a small system, I would say, is needed, so it can be integrated into the bigger system, which is the main grid. So I think this is something that we've been visioning to do it in Indonesia, because that will solve the problem, a lot of problems in the most of the small systems. So yeah, I'm supporting it, and we are really supporting this market for the small one. I think with our small points, we will make a big impact.
Thank you, Pak Victor. Pak Endang is one of the Pak Endang is one of the stream entrepreneurs. You can discuss it. I think we're still waiting for another question. Let me ask. There is I have a question to Mr. Hans, but there is a question to Mr. Lis, to Miss Siti. So I will read the question. Question to Mr. Steve from looking at the model that you have shown for the small scale electrical power from energy, it is already using local material for the popular and then the part. Have you already made agreement with Indonesian companies to produce the other parts? This is from Ephraim Santos Sumba NTT. Please, Ms. Siti.
Yeah. We are still on process to make a partnership with some parties, because we not only make partnership, but we have to create a market together. I think the challenge is not only the production itself, but we need to gather the market. So we will consider partner who has not all, because the financial, maybe it will be the last thing, but to create the pipeline and project target, I think is the second step. So we will consider the partner who have that will or mission as the same mission with us. So we will openly to collaborate with everybody.
Okay. This is another from Pak Erwin Kasim. Mana nih? Pak Victor, this is in bahasa. Pak Victor, apakah pernah melakukan studi kajian supaya bersama dengan perusahaan oil and gas untuk memiliki yang memiliki fasility offshore platform yang produksinya mungkin sudah berkurang tidak ekonomis dan akan di-abandon mungkin untuk dipasangkan win-win secara wind turbine secara win-win gitu. Bagaimana Pak peluangnya?
Iya. Waktu itu pernah Pak ada suatu tawaran untuk yang rig-rig bekas yang nggak pakai lagi tuh di pantai utara Jawa itu ya. Tapi saya pergi ke sana waktu itu, saya coba lihat gitu ya, waktu saya pergi mancing itu sudah tidak layak Pak itunya rignya itu, udah mungkin karatan dan juga, tapi mungkin yang bisa digunakan itu adalah framework cara perizinannya Pak. Jadi saya berpikir bahwa cara perizinan untuk oil rig itu kan pasti penuh dengan analisa dan juga ada studi-studi yang juga dibuat gitu ya Pak ya. Jadi mungkin itu yang saya pikirkan bahwa untuk menancap satu turbin angin di sana itu bagaimana caranya gitu loh. Apa aja izinnya gitu kan. Jadi saya waktu itu pernah saya coba explore gitu ya, tapi saya lihat banyak jalan buntunya itu Pak. Jadi sebenarnya kita juga berharap bisa memakai rig-rig bekas itu gitu, karena selain juga tidak dipakai, lalu itu juga merusak pemandangan di situ Pak gitu.
Thank you. Mungkin Pak Erwin nanti bisa menindaklanjuti dengan apa berdasarkan jawaban dari Pak Victor. So well, and it is my chance to ask to Mr. Hans. Yeah, of course, it will have time. Mr. Hans, you mentioned about the LCOA, and then thanks for this one. Yeah, if we build the offshore wind, yeah, and then we have to compare with other resources in Indonesia. What and where is position of the LCOA of wind offshore compared to onshore one, and also for the solar, yeah, for solar. I mean, I'm thinking because government open now the PLT base. It means base power plant from renewable energy. This means intermittent wind or solar plus the battery energy storage system. So where is the location? The position of the LCOA of the wind offshore compared to other one.
Yeah, no, I think it's a very good question, and I mean, if we look again into Europe and in the other markets, I mean, we see that offshore wind has come down with the cost significantly, and basically can easily compete with conventional power plants, but also with onshore. I mean, PV in general is probably a little bit lower, but we also need to see the capacity factors of offshore wind, which are obviously higher than what we see in onshore or PV. So basically, I think for Europe, I definitely would say offshore wind is already competitive, and I think that this potential is also there for other markets. But we shouldn't forget that obviously it takes a bit in order to get there. So we cannot, most likely we cannot expect that offshore wind can immediately from 0 to 100 compete with that. But it requires also some support and political will to make offshore wind competitive. You need to build a supply chain, and that requires investments, and that basically obviously requires also some stability. And what other presenters already said, you need to see you need to see the forecast. How can offshore wind develop? But then I'm also pretty sure that we can compete with other renewables as offshore wind is doing in other countries.
Yes, I know this is the general question from me. Thank you for the answers. As I said earlier, LCOA is very sensitive because we still have this cost. But of course, with the coal phase out, we hope the government not refer again to coal and coal price. But of course, there will it looks like government to refer to solar plus battery energy storage system. Looks like yeah. Okay, we still have 5 minutes, and then if anybody raise hand, and then we will give the occasion to raise question. Is there anyone to ask to the 3 panelists? Please raise your hand. No, if there is no, I think I will give it the occasion to the speaker. You can ask to other speaker, or you can give the conclusion statement for 1 minute. Please, speakers. Maybe starting from the ladies first. Mbak Siti, silakan. Kalau ada mau disampaikan 1 minute, silakan ya.
Yes. So we believe in the wind energy, and our Indonesian target, we already declared that we want to reach the 100% renewable. I think we can do step by step from the one case project that there is feasible, and I think for the large scale is very challenging, many process. So even in our small scale, we have many challenges also. But I think we focus on how to make collaboration with everybody. I think is the key. We cannot solve this wind energy or another renewable energy project with our own limited capacity. So I think we have to create a stronger partnership and also to solve every obstacles that we have.
Yeah, thank you. Pak Victor, we noticed that your last presentation is very, it is answer for the HISO program using the wind power. Yeah, it says it's around 2 or 3 megawatts. So what is your last statement?
Yeah, actually for the small turbines, you rely on the needs of the supply of electricity to the loads. So if the loads that we can analyze is pretty much it's a small demand, we can create a microgrid system with battery, and then with adding the energy of wind is a redundancy that will solve the problems compared with just a solar and battery supplying the system. So I think with the additional of the wind, it's going to really help a lot for a small system and small area. Of course, they have to have a good wind resources, but for some area that's really perfect for building a wind, I think we have to push and we have to strive for that to get the projects done, because I think some of the small areas in islands in Indonesia, there are about 10,000 people in a small island, but they don't have good electricity there. So I think we can make a difference, and we can help that with the wind energy.
And then the last, Hans, we just starting our market for offshore wind, and then you just come to Indonesia. So what is your statement? Yeah, please.
Yeah, actually, I think I really like the variety of contributions in this session. So from Ibu Sita and Per Victor, I think at the end we believe that the future energy mix also consists out of various energy forms and various participants and various technology. Therefore, I think this was very, very good to see the various different aspects. And yes, we also believe that offshore wind will play a role in Indonesia. Maybe not as mentioned within the next 2 to 3 years, but on the long term, I think we all together as a wind industry should work on promoting the various aspects and various benefits of our industry.
Okay, thanks for all the speakers. And then I think we come to the end of the sessions. There's a comment. There is a comment from Mr. Wahyu to everyone. We come to the end of the sessions. We are very happy, and then we will keep communication between all the stakeholder and then with Indonesian association, also with the government. So, Pandang, any something to you from you? No. I think so. Let's close this session with the big applause for speaker.
Thank you,
Thank
everyone.
you very much.
Yeah, thank you, and bye. See you until later. Be ready to.
Thank you.
Thank you, everyone.
Thanks. Bye. Stay safe.
Bye.
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 The UK and Indonesia are working towards Indonesia's energy transition through the Mentari program. Mentari will deliver inclusive economic growth, electricity access, and support Indonesia's renewable energy ambitions. We work together with the government, financial partners, local communities, and other donors to create jobs, deploy low-carbon energy projects, and fight climate change. The program works through 4 main areas: policy, brokerage, demonstration project, and collaboration and networking. Furthermore, we strive to mainstream gender and inclusion throughout all our activities. Mentari helps to create a future that is built on low-carbon energy and sustainable economic growth, which belongs to everyone.
Innovation and Investment for Inclusive and Sustainable Economic Development project, ISED, is a collaboration between the Government of Indonesia and the German federal government, implemented by GIZ and Bappenas, the Ministry of National Development Planning. ISED's private sector-oriented approach emphasizes knowledge and skills transfer, serving as both a leading character and primary focus.
Building new industry requires a collaboration between politicians, society, industry, and people who want to develop a better world.
The transformation will go much faster than we believe just now.
Years ago, we started to explore. We have transformed into a world-class energy company. We proudly present for Indonesia, energy for a better life. Bukit Asam, beyond coal.
Open your eyes. Look around. The Earth needs us to save it from climate crisis. The question is, can we make a brighter future for the world? Yes, we can. From the soil we stand on lies a better solution for mankind. The Earth provides magnificent geothermal energy that is clean and renewable, bringing eco-friendly resources from underneath, transforming sustainable energy for the benefit of society, working hand in hand meticulously, balancing the life of nature, preserving natural biodiversity in its pristine environment, creating valuable harmony that lasts for generations, providing comfort for all living beings, advancing life without leaving nature behind. We connect people and their surroundings while empowering Indonesia's economic growth and implementing new geothermal technologies. Working with the brightest stars that drive us forward. Perfecting excellence in everything we do. And shifting the future of humanity one step at a time. we have been making our steps, leaving marks for a better future, and heading for what's next, to make tomorrow brighter.
The UK and Indonesia are working towards Indonesia's energy transition through the Mentari program. Mentari will deliver inclusive economic growth, electricity access, and support Indonesia's renewable energy ambitions. We work together with the government, financial partners, local communities, and other donors to create jobs, deploy low-carbon energy projects, and fight climate change. The program works through 4 main areas: policy, brokerage, demonstration project, and collaboration and networking. Furthermore, we strive to mainstream gender and inclusion throughout all our activities. Mentari helps to create a future that is built on low-carbon energy and sustainable economic growth, which belongs to everyone.
Innovation and Investment for Inclusive and Sustainable Economic Development project, ISED, is a collaboration between the Government of Indonesia and the German federal government, implemented by GIZ and Bappenas, the Ministry of National Development Planning. ISED's private sector-oriented approach emphasizes knowledge and skills transfer, serving as both a leading character and primary focus.
Building new industry requires a collaboration between politicians, society, industry, and people who want to develop a better world.
The transformation will go much faster than we believe just now.
Years ago, we started to explore. We have transformed into a world-class energy company. We proudly present for Indonesia, energy for a better life. Bukit Asam, beyond coal.
Open your eyes. Look around. The Earth needs us to save it from climate crisis. The question is, can we make a brighter future for the world? Yes, we can. From the soil we stand on lies a better solution for mankind. The Earth provides magnificent geothermal energy that is clean and renewable, bringing eco-friendly resources from underneath, transforming sustainable energy for the benefit of society. working hand in hand meticulously, balancing the life of nature, preserving natural biodiversity in its pristine environment, creating valuable harmony that lasts for generations, providing comfort for all living beings, advancing life without leaving nature behind. We connect people and their surroundings while empowering Indonesia's economic growth and implementing new geothermal technologies. Working with the brightest stars that drive us forward. Perfecting excellence in everything we do. And shifting the future of humanity one step at a time. We have been making our steps, leaving marks for a better future, and heading for what's next, to make tomorrow brighter.
Recording stopped.
The UK and Indonesia are working towards Indonesia's energy transition through the Mentari program. Mentari will deliver inclusive economic growth, electricity access, and support Indonesia's renewable energy ambitions. We work together with the government, financial partners, local communities, and other donors to create jobs, deploy low-carbon energy projects, and fight climate change. The program works through four main areas: policy, brokerage, demonstration project, and collaboration and networking. Furthermore, we strive to mainstream gender and inclusion throughout all our activities. Mentari helps to create a future that is built on low-carbon energy and sustainable economic growth, which belongs to everyone.
Innovation and Investment for Inclusive and Sustainable Economic Development project, ISED, is a collaboration between the Government of Indonesia and the German federal government, implemented by GIZ and Bappenas, the Ministry of National Development Planning. ISED's private sector-oriented approach emphasizes knowledge and skills transfer, serving as both a leading character and primary focus.
Building new industry requires a collaboration between politicians, society, industry, and people who want to develop a better world.
The transformation will go much faster than we believe just now.
Years ago, we started to explore. We have transformed into a world-class energy company. We proudly present for Indonesia, energy for a better life. Bukit Asam, beyond coal.
Open your eyes. Look around. The Earth needs us to save it from climate crisis. The question is, can we make a brighter future for the world? Yes, we can. From the soil we stand on lies a better solution for mankind. The Earth provides magnificent geothermal energy that is clean and renewable, bringing eco-friendly resources from underneath, transforming sustainable energy for the benefit of society, working hand in hand meticulously, balancing the life of nature, preserving natural biodiversity in its pristine environment, creating valuable harmony that lasts for generations, providing comfort for all living beings, advancing life without leaving nature behind. We connect people and their surroundings while empowering Indonesia's economic growth and implementing new geothermal technologies. Working with the brightest stars that drive us forward. Perfecting excellence in everything we do. And shifting the future of humanity one step at a time. We have been making our steps, leaving marks for a better future, and heading for what's next, to make tomorrow brighter.
The UK and Indonesia are working towards Indonesia's energy transition through the Mentari program. Mentari will deliver inclusive economic growth, electricity access, and support Indonesia's renewable energy ambitions. We work together with the government, financial partners, local communities, and other donors to create jobs, deploy low-carbon energy projects, and fight climate change. The program works through four main areas: policy, brokerage, demonstration project, and collaboration and networking. Furthermore, we strive to mainstream gender and inclusion throughout all our activities. Mentari helps to create a future that is built on low-carbon energy and sustainable economic growth, which belongs to everyone.
Innovation and Investment for Inclusive and Sustainable Economic Development project, ISED, is a collaboration between the Government of Indonesia and the German federal government, implemented by GIZ and Bappenas, the Ministry of National Development Planning. ISED's private sector-oriented approach emphasizes knowledge and skills transfer, serving as both a leading character and primary focus.
Building new industry requires a collaboration between politicians, society, industry, and people who want to develop a better world.
The transformation will go much faster than we believe just now.
years ago, we started to explore. We have transformed into a world-class energy company. We proudly present for Indonesia, energy for a better life. Bukit Asam, beyond coal.
Open your eyes. Look around. The Earth needs us to save it from climate crisis. The question is, can we make a brighter future for the world? Yes, we can. From the soil we stand on lies a better solution for mankind. The Earth provides magnificent geothermal energy that is clean and renewable, bringing eco-friendly resources from underneath, transforming sustainable energy for the benefit of society, working hand in hand meticulously, balancing the life of nature, preserving natural biodiversity in its pristine environment, creating valuable harmony that lasts for generations, providing comfort for all living beings, advancing life without leaving nature behind. We connect people and their surroundings while empowering Indonesia's economic growth and implementing new geothermal technologies. Working with the brightest stars that drive us forward. Perfecting excellence in everything we do. And shifting the future of humanity one step at a time. We have been making our steps, leaving marks for a better future, and heading for what's next, to make tomorrow brighter.